start your session.
Slides are there, so I have to share slides. I will start with straight away. First, we start with entire because I want to share PowerPoint slides. Later on, I will disconnect and start with PowerPoint slide. Okay. Are you able to see my slides, ma'am?
Yes, sir. Yes, sir. We can,
Yes, sir.
we can see slides. Yes, sir.
Wonderful. Okay. Somehow the Google is such that when I go full screen, I'm not able to see all of you. So I will be asking in between.
Yes, sir. No problem, sir.
Okay.
Yes. Okay.
So thank you very much for the wonderful introduction, wonderfully welcome. I'm very honored to share with you some of my thoughts and views which I gathered over almost 3 decades from various conferences, research, interaction with the experts, as well as my association with a number of faculty members and institutions globally. So title I have chosen is Synergizing Smart Energy and Smart Transportation for Sustainable Future. Okay. For any further details, please contact Professor Seema and her team. Okay. Let us begin by taking the blessing of Goddess Saraswati. Om Saraswati Namastubhyam Vardhe Kamrupini Vidyarabha Parishami Siddhir Bhavatu Mesatam. For international participants, we are taking the blessing of Goddess Saraswati, which is considered to be seat of knowledge, to make the last day of this FDP successful, and obviously my presentation very successful. Okay. What we'll do quickly, what is current scenario? What we mean by smart energy and smart transportation. I know these words are there used in different ways. And then how to synergize smart energy and smart transportation, and then how it will open up future possibilities. Some of the things may be happening, some of the things will be happening in future. Some of the research I will be also sharing. Okay, so what is current situation? Current scenario we call it. Yes, we have a transportation system which requires energy in one form or other. Yes, still we have got human energy powered either bicycles or rickshaws, animal energy, bullock carts. Then comes the real one, where is motorbike, cars, or trucks, which requires diesel, and even diesel operated trains, and obviously aeroplane. So this is just gives us we have got varied types of transportation, and therefore we need a varied type of approach. Not one single approach will be sufficient to solve all the problems. Okay. And for that purpose, we need to apply what is known as a smart approach. Okay. Smart approach we have defined or proposed based on our years of experience interaction with the experts. So S stands for sustainable. So whatever the choices we make, we need to comply with the sustainability. Okay. I think we have taken one wonderful session a few days back, and that gives you idea about sustainability. Then whatever we are going to say, we are going to implement something, we should be able to measure and see it. Otherwise, if you don't measure, we won't be able to manage it. And if you don't be able to manage it, then it goes out of control. And both, we are talking about whether it is energy, transportation must be affordable. Okay. Affordable to masses. Then it has got tremendous use. And could be also for masses, sustainable for masses, you can say for masses also. And we should be able to renewable, means renewable will give us regular supply. There is no shock there is a shortage, so there should be a renewable type. And obviously to manage it properly, to make it smart, it is technology driven, tech driven. Okay. So if these 5 parameters are there in either in energy or in transportation, and for that matter, in education also. We can apply this smart approach. Okay, smart. All of you can use it, whosoever you wants to, in various ways. Okay, in even in your career also, same thing. Okay, career also. Same. Let us begin with the transportation. They are talking about low carbon transport system. I think my colleague Bhaskaran has mentioned to you how we can measure this carbon footprint. So obviously, what they are saying is, as far as emissions are considered, there are less emission if you do walking, active travel, obviously, but then there are limitations for that. Next comes the what they call in hierarchy low carbon is cycling. Again, because what we found that we may not be able to work such that there is no emissions. Yes, we can. Okay, we can. Zero emissions we'll be talking about later. But at present, situation is such that there will be some emissions. What we want is low emissions, low carbon emissions. Then comes the public transportation system. Nowadays, many of them are electric driven, so that will also help. But as long as they are using diesel or something, then there is a shared value, okay, communal travel. Then, therefore, that is why we want to shift to electric cars or other types of vehicles which are low carbon travel, cleaner options. And if you really can't do this one, then obviously we have to rely on the petrol and diesel cars. So then it is a carbon intensive. But if you share, it will only reduce the burden. And obviously, most expensive is air travel. It is expensive as far as intensive carbon also. So this is what they call hierarchy. Okay, 1, 2, 3, 4, 5, 6. Obviously, wherever possible, we try to be in first 3 or first 4. Okay. Now let me take you to the land of smart energy and smart transportation virtually, because this is a virtual one. We have a pilot, Professor Shreya, Professor Seema, okay, is there. Professor Seema, you are going to lead us. Board your flights. Yes, she has sent you the e-tickets. Okay. Professor Seema is going to be our pilot now till for this session. She has sent you e-tickets, okay, e-tickets by virtually, and you board the flight. I know there are some challenges. Some of them will be worried about boarding Air India. Then that is why we are given you alternative, and you can board it. Okay, and obviously this is what we call aeroplane. Aeroplane is one of the most carbon intensive. But if you want to go, say, for all of you want to come to Singapore, or I want to travel from Singapore to Kolhapur, okay, I need to take air transport. Yes, I could take other, but it will take a very long time. So aeroplane is one of the transportation systems which is most carbon intensive. Okay, so we have taken aeroplane, but still, because you are virtually coming in a fraction of second, because we are traveling virtually at a speed, we have reached at the smart eco-friendly airport. Right? And you reach a smart eco-friendly airport. Inside, you see a lot of smart transportation, even inside also automatic. Okay, the doors are opening automatically. Announcements are there. You just board it, and there are no drivers. There are driverless vehicles inside. Even robot transfers are there. You can put your hand luggage there. It will guide you there. And you use, again, smart technology to scan your passport and get entry into the smart. In a fraction second, you are reaching. So your luggage has arrived, and I am waiting for you at the arrival. All of you come over here, and then we'll be using some, again, transportation system to visit this smart city, wonderful smart city. Okay. So now from aeroplane, we are all here at this one. Let us dwell a little bit about the aeroplane. Yes, it's possible. Okay, research is going on. Those who want to do research, this is a good opportunity. I think they are working on, okay, hydrogen hybrid turbo engines, okay, which will reduce, as I mentioned, carbon footprint, becoming smart, okay. So obviously they are designing this for the liquid storage of petrol and distribution system. Even blended wing, they were working on a nice, I think we must have seen this one. As a result, it will consume less fuel, so better design, including turbofans, so that we are able to use what is known as innovation in design, innovation in fuel when we are shifting from the current polluting fuel to hydrogen-based fuel or hybrid-based fuel, which will be less polluting. And this is one of the ways, smart, sustainable way, okay? Sustainable way to move. As this is in a research stage, only some companies are working on it, and therefore students, faculty members, researchers, or even for industry people, this is the area you can, those who are in the from mechanical and chemical side can think about the research, even chemistry, okay? Think about a research in this area, okay? Research in this area, and show that there is a scope for using this kind of transportation system. Okay. Yes, some of you might say, okay, aeroplane is carbon intensive, but it is faster. Why not we take the sea route? Okay, why not we take sea routes? Singapore and India is connected by sea route, so why not we consider that one? Yes, it is possible. Obviously, at present, conventional ships, they use diesel predominantly, and therefore they are polluting. Now research is going on, and they have come up with some demo types of ships which uses solar energy, wind energy, batteries, as well as instead of diesel, LNG, okay, liquefied natural gas. And they are demonstrating it, and some demonstration ships are taking test drives in the oceans in various parts. This is another area, okay? If you want to take a ship and want to make it less carbon intensive, then those who are in maritime or mechanical engineering or electrical or electronics engineering, even batteries means chemical and chemistry side, there is a scope to design. So you can do research in one very specific aspect and show application, how it will be used for shipping, okay? Shipping. So that if we take a sea route, then ours is less carbon intensive, sustainable. It satisfies the smart aspect, okay? So, and obviously, so we are going in reverse way. Okay? Suppose we have tried air, yes, then we can try sea route. And obviously, once you are in this wonderful virtual place, you want to travel and see those smart cities and smart sightseeing, then obviously there is a petrol and diesel car is available, but it's more polluting, okay? And I'm informing you that there are certain countries which have made a decision, okay, that, for example, Singapore, from this year, from 1st of January 2025, no new vehicles with petrol and diesel car can be registered in Singapore. Okay, it means you can't buy and can't register. So you have to go for environment friendly, whatever they specified for all new vehicles. Existing are still there. It will take time to phase them out. So it is not an easy choice. There are some European countries which are also doing same way. I think Norway is one of the one they achieved considerable penetration of alternative vehicles. So this is another way, okay? Another way, we need energy, but we are shifting the use of energy which is less polluting, sustainable type, okay? So, yeah, we had it. Otherwise, you must just see, correct? Another part, we want to use this kind of vehicles imagine that you are stuck in this kind of traffic congestion. And those who come from big cities in many parts of the world, is, though I'm showing you, it may be you might say it may be exceptional in few cities. No, it is getting common in many cities. Many cities. Not only that, you get stuck. If it's a diesel operated or petrol operated vehicle, there is a pollution also. The question arises, do we want our cities like this? And if you feel that this is affecting our life, affecting our health, affecting our, okay, the way we do our regular things, then we have to do something about it. Yes, while we can wait for industries, the government, and other things to come to products and services and policies and laws, our side, we can also make some efforts to do the, as educationists, as researchers, to show to them that yes, if we shift, there is a scope for transformation. And if you want to move from here to definitely, otherwise, if you don't do this one, in 2020, all of us were wearing masks. And if this situation continues, we don't take actions and we say, "Chalta hai, jo chalta hai, chalne do," then we may have to start wearing the mask again, okay, for different reasons. That brings us to now, can we shift, if possible, all of them, or some of them, or most of them, from petrol and diesel car to electric car? Obviously, compared to petrol and diesel car, it is a low carbon travel. Okay, electric car. Obviously, electric car nowadays, what are they have been designed? It has come, considerably good mileage has come. Batteries are needed. That is where the major challenge is. Lithium-ion battery they are suggesting, but it has got some other problems. Sodium-ion batteries are also being recommended. Now, what we need is research in this one. Okay, which one is going to give us better one? Combination, whatever. Motors also. Those are from electrical engineering. Motor has become suddenly very important component. Everybody is doing research how to make this motor more efficient. Though it is efficiency is more than 90%, but they are looking at the ways you can improve further. And one of the things they are talking about is use of those rare earth elements, and that is creating a problem. So new motors are coming without use of rare earth magnets. Can we use other types of materials? So this is kind of research is going on because of the changes happening globally. Okay, whether it's war, whether it's supply chain disruptions, or the tariff, whatever it is. Okay, then we need considerable research and development in inverter and onboard charger system, quick charger. Okay, yes, they are showing fast charger, but only for limited one, different types one, and not everybody can afford it. So ultimately, can we go back? A big cars will be able to charge in our garage. That will be the situation they are looking at. Yes, electric vehicle can provide a solution, shifting away tailgate pollution. Tailgate pollution, which is coming out of diesel and petrol one, that will be removed. However, there will be pollution and some carbon emissions when we want to manufacture it. So only thing we are shifting it, but that's still better. Another most important part is because now electric vehicle means not only cars, there are now buses are coming. Later on, we see trains are also there, small vehicles, scooties, everywhere they are coming. What it means is now they need a strong infrastructure. What they call is strong infrastructure for charging infrastructure. Okay? Charging it. And how we generate electricity, that is what will be very important. If we are going to use at present world's top most polluters, China, United States of America, India, and others, okay, they are still using fossilized energy, whether it is a coal or natural gas, to generate predominant part of electricity. Yes, they are using, many of them are shifting slowly towards solar, wind, but penetration is low. Penetration is only maximum it can go is 10 to 15%. So majority it is still coming from fossilized one. So what does it mean? Okay, yes, can we shift to electric public transportation? Yes, metros are coming. Like many cities having metros. Like Mumbai has metro, Pune has a metro, now Nagpur is also getting metro. Kolkata has, Delhi has, so India is there, Singapore has got, London is there, New York is there. You look at big cities everywhere there is a network, and European has got very good network of train throughout the European Union. And Japan has got many of them what they call high-speed train, bullet trains. China is also incorporating that. So what is happening now? When we shift to electric public transportation, we reduce our carbon footprint. The carbon footprint substantially, provided our electricity is generated from non-fossilized energy fuels. That is most important. Okay. Otherwise, if you are using, as I mentioned, if you're using coal or oil or gas, then you are only shifting pollution. So for energy, obviously, we can take measures so that we are in line with the smart energy, wherein energy conservation means when not in use, we must have a mechanism to switch off, either manually or using smart devices, sensors, okay, controllers. Then wherever required, we must start using energy efficient devices. All countries have got the labeling system, Energy Star system or anything equivalent where they specify they have got systematic measurement, and they say if you use that one, obviously it is, that percentage is expensive, but when you look at the what they call is life cycle cost of the energy, then it might become affordable. So that is another one, energy efficient. And renewables are coming. Yes, solar is being now penetrating in most of the part. Efficiency is low. It is not 24/7 type continuous one. We need storage system that is costing more, but wind is there and other forms of renewables are there. So now we need to apply these measures to make our energy smart. Usage wise, generation wise, transmission wise, distribution wise, as I mentioned in my presentations, we need to do that. So I'm going to show video now. Here I have to come out because this is so what I will do is I will shifted and can I, okay, I'm playing now. Okay, so madam, please tell me, are you able to hear or not? I'm stopping. Is it audible, ma'am? I'm stopped.
No, sir, not audible.
Okay, not I stopped it, but can you see that video on the screen?
Yes, sir.
Okay, I will start now. Tell me, can you hear me?
No, sir. Not getting the sound. There is sound problem, sir.
Okay, sound problem. Then what I'll do, I think I have to stop and start sharing. Correct? Just hold on. Allow me to work on this. Wait for the stop presentation and start again. Okay. Are you able to see something?
Yes, sir.
Okay. Now I will start one more time from the beginning. And you tell me
the unprecedented pandemic, climate crisis, and global conflicts have adversely affected energy.
Okay, I'm starting again, starting from beginning.
Strategies for accelerating energy transition towards net zero vision. The unprecedented pandemic, climate crisis, and global conflicts have adversely affected energy transition goals set at the Paris and Glasgow Accords. The top three most significant greenhouse gas emitters, China, the United States of America, and India, have, in principle, set a goal for net zero emissions by the years 2060, 2050, and 2070 respectively. As the world economy attempts to recover from unprecedented pandemics, demand for energy is increasing, and is expected to increase further. Consequently, energy prices and inflation have been rising. While attempts are continuing to address supply-side constraints, they are predominantly focused on fossil energy. In view of almost negligible greenhouse gas emissions and energy security issues, proponents are once again promoting nuclear energy. On the other hand, efforts for the substantial deployment of clean energy resources, including green hydrogen, to address the energy supply, have been made. They are constrained by low reliability, storage, higher cost, and transfer of technology. Measures such as energy conservation, energy efficiency, and clean and green energy technologies in the entire energy supply chain have to be adopted as advocated in the International Energy Management Standard, ISO 50001. In addition, research, development, and deployment of smart, clean, and green energy technologies need to be accelerated. Smart grids, microgrids, smart meters, data analytics, artificial intelligence, and digital twins have a crucial role in the efficient management of the power and energy sector. What strategies can, therefore, be adopted, adapted, and accelerated for an energy transition towards net zero vision is the theme of this presentation.
I would like to thank my collaborator, Engineer Ajay Venappu, who has helped me to prepare this wonderful video. I'm sure you must have gained substantial understanding from this. Okay, so I will continue with our presentation again. So I go to the entire screen. So I will now go to next slide. Okay, so this is what exactly I was mentioning. Okay, what we need is energy network, which is coming from smart energy. Now you know what we are talking about smart energy, which has got various features, okay, including sustainability. And if you're able to get electric power system network at all places supplied by sustainable resources, and then that is powering our electric train, metro, bullet train, high-speed train, then we are moving towards sustainability smartly. Okay, this is what we are saying. What does this mean is now we shift. I know at present we are using predominantly coal or natural gas to using science, technology, engineering, arts, and mathematics, STEAM education, whether it is a solar energy, both photovoltaic, solar thermal, micro hydro, wind, bigger and micro wind, as well as converting, as I mentioned in my last presentation, converting waste into electricity and power, sustainable way. I'm sure, I think last time I mentioned whether you want a destructive choice or sustainable choice, smart choice. Bhakas or Jhakas, smart way, okay? Smart way you want it or the conventional way. Put in chat box, okay? I'm sure most of you will, and this is where the research now should focus on. More and more research should go in this area. And exactly what we're talking about, we are, as I mentioned in the video, is a smart grid. What the smart grid has got? Okay, smart grid has got smart devices. We're managing all different type of resources, whether it's thermal power plant and nuclear power plant and hydroelectric generation station or photovoltaic, wind, whatever, they are managed in a smart way using smart meters, intelligent sensors, into communication system, analytics, big data, and AI, okay, including AI. Okay, AI can be used now so that it is managed efficiently. This is the first part. This is what, when you connect all of them together, including the loads, it becomes smart grid. We need the smart grid. Yes, many countries are now shifting to a smart grid. It's taking time. It will require considerable investment, but till the time it becomes acceptable practice, there is a tremendous scope to carry out the research, training, capability building, and that is where our courses should be also modified to include this. Our research, those who are in this area can do the research in this area, and then you'll find that it is very useful. Even computer, many times computer science students, faculty, whenever I'm sure I'm going to discuss about smart energy and smart, they say, oh, what does it do? It has to do with the computer science. I think it is not related to us. Only it is for civil engineers, mechanical engineers, environmental engineers, or maybe some electrical. And I tell them, no, I think you have got misconception. We have to educate our students, faculty members. It doesn't matter whichever faculty come from. All of you will be required for making our energy smart and making our transmission smart. And this is what you should be solving the problem, not some phony problem, okay, funny problem, which is only theoretical one, which has no actual, only just likes on Facebook or images of the Facebook, and then those are not going to give us much. This one is going to really affect and make change to the people's life. So I appeal all those who are studying AI, big data, machine learning, computer science, infocom, start applying. Application should be to our basic things: energy, water, and transportation system. We should do it. No point having very fantastic AI algorithm, doing it something funny thing, and which is not solving our regular problem. We are inhaling pollution. We need to shift. And that for this exactly, I'm going to share this one, why we need to shift using this simple approach we'll call smart energy, smart transportation grid. Okay, grid, smart grid, like, okay. On x-axis, you've got smart energy. On y-axis, you've got smart transportation. Now, obviously, when we start, we have low smart energy. Low means we're only using little bit of it. You're not going fully, because AI and data science, they are busy doing someone else's work, which is really not producing much benefit to the masses, especially in developing countries. You want to solve somebody else's problem, thinking that they will give you money, but they are also firing them up. They are also laying them up. So therefore, shift your application. Start taking this energy, smart energy and smart transportation related problems. Obviously, at present is low. We are in the brown quadrant, and our goal is this is the emerging one. Is emerging. There's still tremendous scope. Emerging means there is tremendous scope to do research, tremendous scope to come up with your startups, tremendous scope to start your own entrepreneurship program, incubation projects, you name it, and courses. This is how your entrepreneurship should come in. Smart energy, bring in more and more of them. No point just firing something and people like idiots are following Elon Musk. Okay, we want to go to space. For what? Make our life better here. We need that energy here on the earth, not in the space. They are idiot people there. They have got a lot of money and they are filthy. They are wasting money like this one. We should tell them, bring that money for the making life of common people better, not just going somewhere for sake of showing off. We must do that. So enterprises should, okay, unless we the people tell that, and even if needed, with a strong one, if you're an influencer one, write that one rather than going somewhere for no hope. Same with transportation. The transportation, not going to space. Transportation is smart. In your cities, in our towns, better connectivity, no pollution, almost zero pollution if possible. And using our resources for the benefit of the people, not for the only benefit of the few. if that is what exactly it is, not smart way, it is idiot way, it is dumbest way, using smart technology for dumb reason, dumb purposes, okay? But if you use it for more smart transportation, more on high level transport, the smart energy, then we are going towards that one. This is where we should force these guys, okay? Tell them what you are doing is useless, okay? Whether you are taking any, okay, big melas or big rallies or road shows, all waste of energy, okay? Waste of energy. They should change that one. We should use it for the benefit of the people. Benefit of people, which will create jobs, which will provide better opportunity. Our health will be better. Sustainable way. Smart energy, smart transmission grid. This is how you do systematically. Okay, our courses, our research, our student projects, our community service, our interaction with the industry has to be in that way. Okay, solve the problem we are facing today. Then we will not, because it will create so many jobs and so many opportunities that will be a jackass vikas. Better one. Another development we are knowing it happening is fuel cell. Yes, at present it is in research stage, it is expensive. But here idea is use hydrogen and electrolyzer to convert that into electric power, where the emission is only water. So hydrogen, oxygen coming together and generating electricity. That is where they're talking about low emission or almost zero emissions. Yes, this is doable. It is coming. However, at present it is expensive. It needs more research in all aspects, material aspect, in management aspect, in control aspects, in managing flow of hydrogen and oxygen and making it catalyst, coming up with a better catalyst and better material. Tremendous scope for the research here, so that this fuel cell can go into what they call zero emission hydrogen fuel cell bus or vehicle. So now this is how exactly we are shift using smart energy into smart transportation. Obviously, if there are no emissions happening, you can see how will be our cities and our places. Okay? This is where Elon Musk should put his money, not in those idiot things. Okay, you like surprises? Okay, I know you may be liking surprises. So let's think about it. There is another one. I'm going to show another video later on. Okay. Is sound coming or not coming? Someone can tell? Yes, no?
No, sir.
No sound, okay. Okay, I will try this one. This is always problem because this is a big file. I may not be able to play directly. But, I will continue now and then come back later. Okay. So what we are looking exactly here now, how we can use smart energy. Smart energy, which is coming from solar, wind, and other sources, including hydrogen. Now there is a good movement because solar cell prices have gone down. So rooftops, solars are becoming common thing. Many places they are using it, and capacity now, because still, though they are being used, there is still need to improve efficiency, as I mentioned. Okay, efficiency, improve production, improve how they can be connected to our regular devices. So don't consider that it has been done if there is no scope for research. There is scope for research. And then this is powering, this is giving energy, electricity, which is predominantly electrical form, to various forms of transportation, smart transportation. Yes, as I mentioned to you, we are going to use aeroplane, but if you want to catch aeroplane, you have to start from home, and from home you need to use either own vehicle or public transportation system. Nowadays, they are talking about automatic vehicle control system, in which right from your home or your college or institute, your car or vehicle starts. It is been managed using smart sensors, smart devices, so that it can take the least or lowest possible path, so that it can reduce your consumption. Second, it can reduce your emissions. Third, it has got a capability to avoid collusion, so anti-collusion devices, okay, adaptive control systems, which can stop vehicle-to-vehicle collusion, and maybe it has also got smart devices which can sense other things also. Obviously, some of them are doing automated guided vehicles, AGVs they call it. There are some challenges. Probably they still need good combination of human intervention wherever there is a failure coming, or if the smart devices are not able to sense it properly. And using that one, like not going 100% autopilot, but under the control of pilot, okay, under the control of pilot ultimately, so that you are able to manage it. That is one part. Signals, so those who are from electronics, sensors, tremendous. There will be so many IoT sensors will be deployed. We're talking about roughly by 2030 or 2050, more than trillion sensors. Okay, which then you have got big data coming in, sensors employed in the vehicles, in the places, on the road, on the buildings, and various parts. Okay, so that each and every corner is covered. Even some places they are thinking about using our electric poles, which can not only give you street lights, but at the same time, it can work as a smart sensor. So it has got smart sensors so that you are able to manage. Okay, so that navigation is easier. They are controlled through satellite. They are controlled through various devices which can be deployed using your smart devices you carry all the time. Other vehicles also can be controlled that way. So you have got complete control. Nowadays, they are thinking about having an automated control system. In the control room, you are able to almost manage and see, so that crash avoidance is there, safety of the system is maintained, and if there are congestion charges, there are certain countries we have started like it's like a toll. So toll is automatic. You don't have to stop there. Stop there is automatic. It is taken automatically through the sensors, and traffic signals are also managed such that there is a minimum congestion and maximum possible speed, so that you can reach on time. Can you, yes, WLAN, you name it, okay, all those info communication devices needed outside, inside, can be deployed, including satellite communication. Okay, now satellites communication, then you, same thing for the as I mentioned, for electric transportation or public transport, metros, those cities where you have got metros, you have got metros control system. They can be managed in the same way. Even ferries, if you are using water for transportation system, those who are nearby seas, they can use it. And obviously, aeroplane is there. Okay, all these are now managed through appropriate smart devices, so that they become smart. And okay, they use sustainable type of fuels, so that emissions are also, we have put that condition also. Smart means that condition has to be there. Okay, sustainable condition has to be there. And when we, on the one hand, we have got smart grid, smart energy coming. We've got all these devices in a city. They are registered and managed. And we have got cloud transport system app on your mobile, okay, on your mobile, which can help you to plan your journey, day-to-day journey, or you're going for some business overseas, or even you are traveling to meet your relatives in other towns for pleasure, holidays, whatever it is. It can be now you can decide your itinerary online, and using AI, they can give you advice. Okay, I want to have my uh, transportation system for my travel such that it is using more and more sustainable type of devices. It is less polluting type, affordable one. Okay, and then it can give you itinerary. Okay, maybe from which place to which place you want to use bicycle or electric vehicle, okay, or electric taxi or electric car, shared car or electric bus. And if you're traveling overseas, whether you want to even optimize use of aeroplanes and ferries and your other transportation system, so that all this is now completely under your control. This is all smart devices. If you are able to do that, if this one we can achieve, then all of us will be using both smart grid, smart energy, and smart transportation together. And that will make our life better. Okay? That is what exactly we are proposing. It is not easy to get it, but that is where research can be directed. Now, you are going to get huge quantity of data. That is where now once you have got data and your system is there, now you can put machine learning here. Machine learning, it gets the data and accordingly it just learns and then gives you the better solution. So machine learning can also be integrated here. AI is definitely needed. Big data is already there. Okay. And not only that, okay, suppose you want to troubleshoot, something happens, okay, suddenly there is a failure, how to do it fast way. That is where your skills will come in, training skills will come in, how to troubleshoot them at a faster rate. This is how we are recommending a vision for all of us. Now, after sharing with this one, I would like to ask a question to all of you. Is Make in India, Digital India, Smart City, Clean India, Self-Reliant, Vikasit Bharat vision feasible without quality, secure, and reliable availability of affordable, smart energy and smart transportation? You can put in chat box, or somebody want to. Is it feasible?
Yes, sir. Yes, sir.
Without this is feasible, or you want this?
Yes,
one?
sir. It is.
Then and there. Unless we have got affordable, smart energy and smart transportation, Vikasit Bharat vision will not be possible. I'm asking question, is it feasible without quality, secure, and reliable, availability of affordable, smart energy and smart transportation? If you don't have this one, then it is only on paper that vision. We need to move in that direction. Therefore, we need a good synergy of this smart energy. This is what exactly we are promoting also. Synergizing smart energy and smart transportation. Okay. Synergy, a vision, which all of us can promote. All of us can play a part with. Whether it is a research, whether it is a coursework, whether it is a working together, industry projects, student projects, community work, whatever, okay? The question arises, what is your action plan? Yes, you have attended this FDP, today the last day. What are you going to do after this? Get certificate and then go back to the old ways? Or you want to take up something challenge? Do you enjoy taking up challenge? Put in chat box. Enjoy taking up challenge? Challenge, okay. It's not easy, I know. Okay, I'm giving you one assignment. You can call it assignment, it's for your own purpose. that you are decided to focus on one specific potential opportunity to take up synergizing smart energy and smart transport related projects, ideas, whatever, and prepare research proposal, technical case study, or article. Choice is entirely yours, okay? You decide, because you do this one, it will be for your own benefit. It will start your research. This is what, and I will request later on you can submit to Professor Seema, madam. She can create something, all of you can write just few pages of article, research proposal, technical studies, whatever you feel, okay? I will leave it to madam to give you that time frame, 1 week, 2 weeks, write on based on, if you want to just write based on our two presentation also, okay? Or if you want to write your article based on entire FDP, nothing like that, okay? Go ahead, you can use some information we provided and then use in your articles, in your technical case studies or research proposals. This is how you should promote now, okay? I would like you, each one of you, to share this one, give short presentation or share, put on your social media how this is important, why we should move this in this direction. Okay. Yes, as I mentioned, we can interact on the LinkedIn. Please let me know. I will be happy to. And we have been doing this not only for the university which has invited us. We are doing it for many associations. Okay, IEEE, World Energy Councils, International Energy Foundations, different types of program. And if you feel that any of these programs are going to be useful for your organization, your colleagues, your friends, students, okay, send us inquiry information through Professor Seema madam, and then we will be very happy to collaborate. Okay, we had a wonderful symposium in 2022. We call Global Symposium on Deepening International Collaboration. Yes, we want to collaborate. We want to collaborate with each one of whoever is interested. Collaboration in what? Collaboration in sustainability, collaboration in transportation, collaboration in net zero, collaboration in education, collaboration in smart. Okay. So now I'm going to share with you a short video. So allow me to go back and stop presenting and stop sharing again. Maybe just few minutes, okay. Okay, is it visible to all of you? Please.
Yes, sir, it is visible.
Again, I would like to thank my collaborator, Ajay Venappu, who has created this wonderful video. It's not generated by AI. So we are back again. It is not generated by AI. Okay, no way AI can do it. No way. Okay. So this is where we are now. We'll come back to our regular presentation again. And the reason I'm showing this one is because we are planning next international global symposium on deepening international collaboration in sustainability, decarbonization, net zero, and AI, which will involve smart energy, smart transportation, and hydrogen, whatever you measure about it. Okay, so this will be there. We are planning in 2026. We'll send information through MAM, Professor Simaji, to you, all of you. So what is it now exactly? Synergizing smart energy, smart transportation, that is bringing the grid. On x-axis, low to high, we have got smart energy. Y-axis, we have got smart transportation. Yes, electric vehicle is one of them. Hydrogen vehicle will come, hybrid will come, any other type of vehicle, which as long as they are satisfying our smart definition, which we mentioned, smart for mass customization, okay, affordable, then is a renewable and tech-driven, as long they are able to do it. Yes, there are many. Yes, electric vehicles are coming, hybrid vehicle are coming, plug-in hybrid, okay, all they are coming up, and whenever they become commercially viable, affordable, people will start taking up. There are also goals using different types of, okay, I know there is some concern about mixing ethanol, blending ethanol with the petrol and diesel at present, but we say something better than nothing, because if you use 100% diesel and pollution is higher, if you can blend 10-15% of ethanol, then accordingly you are reducing pollution. That is the only thing. And you are also reducing dependence on the foreign oil. That is another advantage. Okay, so it can be done that way. So our goal is, yes, wherever we are not saying that we will be immediately at the sustainable quadrant immediately. No, not possible. Some of us will be an emerging one, probably most of us, and then we might take, depending on the resources available and how it is moving, we might be taking a path towards the smart energy more. And while still waiting for smart transportation, in some places there may be penetration of smart transportation has happened and it is going more and more, but then their energy they are getting is from fossilized one, so they can now start looking for smart energy devices, how they can improve their energy using smart energy. And in combination, it is used systematically over a period and lead us to the sustainable. This is where exactly we want to go in. Yes, it will take time. It is challenging. There are many hurdles, many obstacles, not easy. And that is where if it is not easy, challenging, there are many obstacles, it means we have a scope to do research and show them more innovative solutions, enterprising solutions. Okay. Yes, incubation centers can be there in the institutions for setting up their startups, because obviously it takes time, and that is where if the funding is used, research, we in India need to focus more on the innovation in the areas where it can help our community people, masses. Not only those, I think, as mentioned by some of the ministers also, that only in delivering in 8 minutes your food or something. No. Yes, continue that, but we need more innovations here. If we don't do this one, yes, there are other countries which are moving faster than us, and then we will be staying behind, and then they will be complaining, hey, how come others? They are import more and pay more tariff if needed, more taxes. What is our choice? If we want to do it, we should be this way. Exactly. after sharing with you, taking you around the wonderful smart transportation system, smart devices, how it can be done, I bring you back virtually to your own places. Okay? Our pilot is there. You are using green transportation, smart transportation to reach to the airport. Inside airport, you are using smart eco-friendly devices. Your luggage is also automatically sanitized and transported on this one. You are using app to board your go to the gate, board your plane. Your everything is smartly scanned, and you are ready to go back. Obviously, if you are still comfortable with Air India, board it. Otherwise, Singapore Airlines is there. After visiting all these wonderful places, Madam Professor Seema ma'am is now taking us back to our own places, wherein you will go back and using that app, choose your hotel. Thank you. Om Purnamadam, Purnamidam, Purna Nidashase, Purnasya, Purnamada, Purnamidvam. Let us make this one happen by systematically synergizing smart energy, smart transportation for system of the future. Thank you very much for giving me an opportunity to share with you some of my thoughts and views. In this one, I bring back ma'am to. So I think we have some few minutes. We can take some questions. Ma'am, your comments, your views. Anyone want to give their views? Most welcome.
Hello, participants. The floor for question and answer is open. So you can ask your question or you can put it in chat box. So there is one question from Krishna Kumar Joshi. Are there any e-crafts and e-ships, sir, being researched for?
Yes, I have mentioned in my presentation. At present, industries are doing research. Airbus is doing for the aeroplane. For shipping, also there are merges. They are doing it now. Maritime industry, the institutions are trying to collaborate with them. So find out, and if you that interests you for doing research, good, take it up.
So one more question.
Business world. Go ahead.
One more question from our participant. What role do ICT, information and communication technologies, play in a smart grids?
Thank you very much. Okay. Maybe I have to show that slide one more time to show them in Procom. Is that okay? Maybe I show that slide one more time. Okay. Touch screen. Looks like my friend has missed out that. Correct? Okay. Let me bring this slide, okay. Is it visible, ma'am? Right?
Yes, sir. Yes, sir.
Now, do I need to address this one? You can see so many infocom sensors devices here, correct? There is a tremendous role, okay? And it will have a critical role to play, infocom, okay? Infocom, sensors, okay? Your good programs, your machine learning, you name it, okay? Because so much data is going to come, okay? Smart grid requires infocom. So both ways, smart energy requires infocom, smart transportation requires infocom. When you synergize them, you require more of them to integrate them. Am I answering your question? Cloud transport system. App is also required.
Yes, sir.
Okay, so because this one answers that question straight away rather than I'm describing only, I show one more. Okay. Yeah, go ahead. If you have any comments to make, need not be questions only. Okay, hey, what is it? How we can bring it to masses? That is most important part. So each and every college and institute, okay, whether it's engineering, management, or science, we should start doing research in this field. Okay, that is very most important part. If you're doing it, congratulations. We should bring in courses in this area. Okay, rather than just having isolated courses. We need courses that have got direct applications. We call real world problem solving. That is where we prepare our graduates for the industry. If you only have got theoretical problems to be solved, okay, just scan several images and then try to make out which image is better. And that's, yes, they will learn about the programming, but they will not be able to apply. I still get requests, many of them, they learned Python during this COVID time. They say, oh, sir, I learned Python, but I don't know where to apply. Then I shared with them our IEEE resource, and they are able to now see because they need applications. So whether you are now in the time for the multidisciplinary, I don't know why we are stuck in giving the specialized degree. I think we are so behind, okay? Maybe 100 years back I'm telling you, okay? We are still giving those specialized degree when industry is asking for multidisciplinary. Why we are giving specialized degree? We should be going back to multidisciplinary type of education. That is where I think we'll be very happy to conduct that. Multidisciplinary education.
Yes, sir. On the behalf of the Ashok Ramani Group of Institutions, I extend my heartfelt gratitude to Dr. Deepak Vaikar sir for sharing his expertise on smart energy systems and smart transportation systems. Dr. Vaikar's presentation was rich with knowledge, offering us a comprehensive understanding of how smart technologies are shaping our future. His global experience and passion for sustainable development resonated deeply with all of us today. We appreciate his clear explanations that made complex topics accessible to our diverse audience. Thank you, sir, for your engaging talks and addressing our questions thoughtfully. Thank you, sir.
Thank you very much, sir.
Thank you, Dr. Chetan. Thank you, Professor Seema. Okay.
Thank you, sir. Thank you very much.
Okay.
And we'll be in contact with you, sir. In future, we'll require your help. Yes, sir.
We'll be very happy to, because we are there to share. Okay.
Yes, sir. Yes. Thank you, sir.
Yes, sir. Thank you.
very
Thank you.
So
Ms. Shreya? Yeah.
Yes, ma'am.
We'll continue for next session.
Yes, ma'am.
Okay. Thank you.
Thank you. And later on, please, Professor Shreya, please share that nicely composed, prepared.
Yes, sir. Sure.
Okay.
Yes, we'll send, sir.
Sure,
Thank
sir.
you very much.
Okay.
Thank you.
Dr. Chetan, shall we start next session?
Yes, ma'am. Sir, I already joined, sir.
Yes.
Ma'am.
Yes.
Okay.
We can start.
Yes.
Yes.
Now we are moving towards our next session. We are lucky to have Mr. Sanjeev Sharma sir with us today on the session number 12 about cyber security for critical infrastructure protection. On the behalf of the Shri Balasaheb Mani Shikshan Prasarak Mandas, Ashok Ramani Group of Institution, I welcome you, sir. Mr. Sanjeev Sharma sir, cybersecurity solution professional, ABB Energy Division, is seasonal professional with over 2 decades of experience in technology, digital solutions, design thinking, and OT cybersecurity. He is currently associated with ABB Energy Division at Cybersecurity Solution Professionals, where he supports customers across energy, utilities, oil and gas, chemicals, and pharmaceutical sectors in IME region. In its current role, Mr. Soma helps organizations strengthen their cybersecurity risk posture and achieves compliance with IEC 62443 standards, national cybersecurity frameworks, and ABB's advanced cybersecurity portfolio. His expertise lies in bridging operational technology, informational technology to deliver the sustainable cybersecurity strategies. Prior to this, he worked with the ABB Ability Innovation Center, driving digital transformation initiative through customer experience mapping, collaborative operations, and analytics-driven solutions. Thank you so much, sir, and welcome you.
Thank you. Thank you for that kind words. Am I audible?
Yes, sir.
Sir, welcome, Dr. Sanjeev Sharma, sir.
Welcome, sir.
Yeah, I'm not a PhD holder like many of you, but I agree with what I was listening to what Mr. Deepak Vaikar was mentioning. I like the way you're introducing. So I didn't know that I was doing so many things. So I can also, so I can also add to some of these things just to. So I'm part of a company called as ABB. Currently taking this call from Bangalore. Because of some personal reasons, I was traveling in between, so could not attend the previous sessions. Apologies for that. Even today morning, some urgent things because of which I could not take Professor Dogar's call. So nevertheless, I'm here right now. So I work in a division which is also called as energy. So the previous topic was of high interest to me. So we serve a lot of customers in the oil and gas sector or power sector, any kind of manufacturing, chemicals, increasingly pharmaceuticals. So those are the range of customers where we provide our systems, and I am part of a team which ensures that systems are always secure. So that's my brief background of the job that I'm doing currently. I look into our business sales for a region which covers India, Middle East, and Africa. So a lot of very hot countries, if you ask me, in terms of cybersecurity threat perception or geopolitics. All these get intertwined when it comes to critical infrastructure. So today's topic that I'm privileged to be in front of you is how to protect some of our critical infrastructure. So what is critical? There are various well-laid definitions. Some links are there in today's presentation. But basically anything which helps the country move forward, which is absolutely essential for the country's working, country's progress. So all our core sector comes into that. So you can think of electricity, mining, gas, transportation. Previous topic covered a lot about transportation. So all this comes under what is called as critical. And then if there is any machinery, equipment, systems which are running those kind of critical sectors, then those are counted infrastructure. So critical infrastructure is something which is of extreme importance to all the countries, but more so to countries like India. And in the recent past, we have been through some very tough situations in which we were able to successfully defend our critical infrastructure. So today's topic that I'm speaking is about how do we provide cybersecurity for operational technology. I'll also come upon what is operational technology, but in operational technology, for critical infrastructure, what is required, what kind of thought process is going on in the minds of the government, what kind of R&D topics are there, why is all this is needed, what happens if it is not there, what are the future trends. I have a list of slides, but I would prefer if this could be conversational. If you have got any questions, you can ask me up front. If you have seen some of these content, if you have heard about it, please share your thoughts. Not at all a problem. I am more than willing to discuss upon that, because cybersecurity is a very, I would say, very wide topic and also a very deep topic. So depending on where one comes from, there are a lot of things which come under cybersecurity. It is a topic which is very intuitive. Everybody uses a smartphone or a computer, does online banking, does UPI. So everybody is familiar with cybersecurity in some form or the other. But the topic that we are discussing today is about cybersecurity, which keeps our plants running, our factories running. So what kind of cybersecurity would be useful there? How do they perceive a threat? So that is my line of discussion in today's presentation. With that, allow me to share my screen and just give me a moment. Okay. So in the meantime, I was listening to the previous session. There was one question about electric ships. So I do know of one such ship which is purely electric, and we are supplying for that. So I'll share that link in the chat window after this presentation. You can read about it. In the Niagara Falls, there is a ship called as Made of the Mist, which is purely all electric. One of the first ones to be in commercial operations. So there are a lot of other examples, but thought of just sharing that. Hope my screen is visible.
Yes, sir.
Okay, let me go into presentation mode. So Google sometimes behaves differently on different computers. Today, I hope I'm lucky. Do you see the presentation now?
Yes, sir.
Okay. Thank you. So thanks once again. So cybersecurity for critical infrastructure, that is the topic that we are discussing today. Let me see how we can minimize this. Okay. Just give me a moment. I'm struggling a bit with Google because it is not allowing me to work in a normal fashion. 1 second, please. I think we should be good now.
Yeah, it is
Visible?
visible. Yes,
Okay,
it is
thank you.
visible.
Thank you.
Yes.
Thank you. So I'm on a single screen. If anybody has any question or any topic or any comment, please ask straight away. Okay. Thank you. Yeah, so I've already covered my introduction. I'll go to the next slide, which is about. Yeah, so we in ABB, we have a very strong emphasis on safety, physical safety as well as online safety. So in today's call, wherever you are, be aware of your surroundings, and if there are some local rules or local procedures, please be aware of that. Understand your escape routes. Please help any visitors who are there in your area. And if you're driving, please stop. All these presentations contents will be shared later on, so do not worry about that. Or you can skip this, but do not try to attend this call while driving. And since this topic is about cybersecurity, when you're online, do not click on any suspicious links, especially the ones which come on social media, especially WhatsApp, Telegram channels. Do not share your OTP or any kind of passcodes which come to your mobile with anybody. And in case of any phone call that you get claiming to be from a government official, please disconnect immediately, or inform somebody if you are not able to disconnect. And 1930 is the cybercrime helpline. You can call that as soon as possible. So there have been instances among my known community where people were not able to do such kind of prompt actions, and they were caught up in that. So even our honorable Prime Minister has spoken about this particular kind of threat, which is there mostly in India, called as digital arrest. So safety is of utmost importance, physical safety as well as online safety. Thanks at the start of this presentation to all the people who are behind organizing this. I saw there are about 100 people in the call, which is a tremendous effort to run this program for 6 days fully online. So thanks to the management at Shri Balasaheb Shikshan Prasarak Mandal's team. I have been in contact only with Dr. Dogar Sani, so I know that there are many other people involved. So thank you to the entire team. And thank you to all the participants for joining today's session on a Saturday, taking time, especially in a topic like cybersecurity or the list of topics around smart manufacturing. So thanks once again for that. And this being Ganesh Chaturthi season, and Pati Bappa Moria. So this is what I have been my entire schooling, childhood till college, and then initial part of my career I was in Bombay, a brief stint in Japan, and then I now since about a decade and maybe about 17 years in Bangalore. So Maharashtra, Bombay is always close to me. I hope to meet you in person. It has not happened recently because of various conflicting schedules, but I hope the next time when I meet, it will be in person. So with the greetings of the Lord, let us move forward. So today's topics, a brief intro about what cybersecurity. As I mentioned, cybersecurity can be very, very easy to understand, but there are some topics which might take a deeper perspective. And when we're talking about cybersecurity, it is of course connected to the digital part of business. So what happens? Why does digital business expand? And once that happens, what are the drivers for that? Because as and when digital expands, you will have need for more cybersecurity. We'll talk a little bit about what kind of talent is available, what kind of talent might be needed in the near future. I would also like to spend a little bit of time around information technology and operational technology cybersecurity. So IT and OT used very, very frequently. My area of work and today's presentation is around operational technology cybersecurity, that is OT, which means the cybersecurity which is used to keep our systems running. So in your house, if you've got 5 gas coming in, it is coming because of some system which is enabling the gas to be delivered from whichever gas manufacturing site to your home. So those kind of systems are also various kinds of technologies, and they run on various systems which are computerized. So and things are in operation. So the operational technology systems are the ones which are under counter critical infrastructure, and then you have cybersecurity for that. No topic on cybersecurity is complete without mentioning about the regulations. So a lot of countries, as I spoke earlier, especially in this part of the world, there is a lot of threat which comes in because of geopolitics, because of the kind of relations we have with various countries. So in such a scenario, a lot of regulations come into play to ensure that systems are safe and protected. We'll take a brief glimpse because this by itself is a topic for more evolved discussions. I will also do a brief walkthrough about what we as ABB do in terms of our portfolio. Q&A is always there at any point of time. If you have got a question, if it is something which I can answer immediately, I will do that. If not, give me some time, I'll get back with an answer. So that's the broad agenda for today's session. I'll start with a little bit about what ABB does. Some of you might be familiar, some might not be. So we are divided into 4 business areas, which is called as electrification, motion, automation, and robotics. So electrification is where all the electrification, as the name suggests, all our breakers, switch gears, all come under this business area, and there are multiple divisions under that. Under motion, we manufacture different sizes and capacities of motors. Automation is where the business area in which I come from, which is automation for any process. It could be manufacturing something, it could be drilling something out, it could be smelting something. So all that is a process. So how do we automate that? And fourth is robotics, the robots that we manufacture as part of our offering. So these are four broadly known business areas in which there are multiple divisions. In automation, there is a division called as energy, where I belong to. And a brief glimpse about ABB in India. This might not be well publicized, but I thought of for this audience, this might be useful because we do a lot in India. We just completed 75 years of manufacturing in India. Apart from that, there are also R&D services that we render out of India. The head office for the R&D is in Bangalore, and then there are also business services that we offer. Since this topic is about smart manufacturing, we have about 5 manufacturing locations in India with 25 plants. Most are under various levels of sophistication. The one in Bangalore is an Industry 5.0 plant. Then there are multiple sales officers, a lot of channel partners, close to 11,000 employees, and more than 5,000 third-party employees, contractors. Gender diversity is this figure has been pushing upwards. Now it's at 18%, and we also export to more than 30 countries out of India. On the right-hand side, you see some of these screenshots of our campuses. Whenever possible, do try to visit these campuses. These are most of them are water positive. The certification is pending for many of them, but the Bangalore campus is the one which is entirely green, which means that net energy is on the positive side for us. So that's a brief bit about ABB. As you see, it is spread far and wide within India, and so we also do our bit towards nation building. So whether it is robots, which are about 9,000 plus and counting, all these are monitored from a center in Bangalore. In case of any service need or in case of any problem, this can be attended remotely from Bangalore across the world. If you're having a car or if you have used a car, good chances that it was painted by an ABB robot. Most of the leading car manufacturers in India are using our robots for robot painting and a lot of body shop work. 60% of oil and gas which is produced in India is monitored by one or the other ABB systems. Same goes for solar projects. Our motors play predominant role in energy savings. Metros, a huge majority of metros have some kind of ABB technology or the other under electrification. We are very strong in pharma, where a lot of applications for drives. Increasingly, airports. Sustainability is one of the strong themes for airports. So, more than 60% of the airports in India use ABB electrification solutions. Cement has been a very strong business for us. More than 90% of the companies in India and elsewhere use ABB systems for that. Railways is a huge consumer of ABB traction converters. Pretty much available in all the states of India. And increasingly, we're also a leading presence in hyperscale data centers, especially with topics like AI and machine learning booming up. The business for data centers is also going upwards. If you have seen or read the Reliance presentation yesterday, there is a huge emphasis on data centers as well. So this is a short glimpse about what we do in India and from India to the world. So, and this has been a growing business for all of us. Now, so coming to the topic as to what is, I mean, we saw some of the applications from the previous speakers. So what are the business drivers for digital? So why does somebody want to do digital business? So what we have seen is that digital has always been there in some form or the other. It has got a very strong definition now, but if you look about 6 to 7 decades back, there was always something there. So even though we might not have termed it digital, so this is the evolution, a quick glimpse into that from the 60s, where we had physical digital signal processing. So there is something called as signal processing happening at the chip level, micro computer level, and then it sort of evolved into what we call as a distributed control system, a DCS, in the 70s and 80s. And this is where the first generation of automation was set out in the fields, in the plants. Then it sort of evolved into the networks. So the controllers and the DCS, they got integrated, and then there are a lot of operational technology networks which started emerging at the site. Then we move into what we call as the current avatar of process automation systems, where we have the operating system, which was on more commercially available systems. A lot of inbuilt hardware came in, then a lot of combinations came up. Today, what we see is these are continuously connected systems, not fully autonomous, not because of technology restraints, but because of sometimes regulatory constraints, or the local land will have some rules. So, but systems or the technologies today are capable enough to be autonomous. So this can run automatically, and they can also improve the operation. So this is where the journey in digital has been in industrial operations. So whether it is shipping, whether it is ports, whether it is factories, this has been the evolution of digital. And why it has come about like this is because in an earlier era, there is a lot of focus on automated systems. On the left hand side, you will see that there are devices, and there are some computing mechanisms which can be done closer to the equipment, or it can be done at a slightly abstracted level, what we call as a cloud or a hybrid cloud. But here the control loops have to be very tight, near close to real time, could be in milliseconds or microseconds, and then it shifts to the right side where you want to optimize. So that is where you have generated a lot of data, a lot of information, and try to process that information to see what can be done, how can we solve, what kind of new perspectives can we bring about. So, and that could be in response times of days or weeks or months. But that has been the journey that we see from real-time control towards in which there are automated decision makings towards autonomous decision making. So earlier topics we spoke about pilotless aircrafts or vehicles. So what kind of optimization goes into that? What kind of data is there? What are the control loops? So this is where the mega trend of moving from automatic or automated systems towards more autonomous systems. And why we'll come to this is because in all the systems there is decision making, and wherever there is decision making, there is data. So it's a database decision making. So if you see the way the data has been utilized from a decadal view, if you go back multiple decades, so initially there was information. So systems were just trying to capture and share information. Then the connectivity started improving. So there is a functional role for the data. Then it became cross-functional. So now everybody wanted to see what is happening. What is happening in my entire site? What is happening in my entire plant? So, and then trying to make sense out of that. Why such and such things are happening? So there is a mix of data points. Could be for different functions. Then the idea was about, okay, can we predict if something is going to happen or what is going to happen? So predictability came as a very strong point. Then it came to adaptability as to how can we adapt and make changes accordingly. So this is where the very strong point of self-optimization comes in, which we can term it as Industry 4.0. But this has been one view of how the data has been utilized so far, right from information towards adaptability. And all these data capturing systems, data recording systems, data decision-making systems, they all require computing power. And wherever there is computing power, there is a need to have cybersecurity. So if you see what is happening at a very, India is a very great example. If you see what is happening is that in terms of industry and society, if you compare to like when I was in college about 2-3 decades back, so compared to what it was and what it is now, so we are much more technology dependent. There is a lot of technology which is available only in India. So a lot of manufacturing which happens only in India. So how do we, from a business perspective, there is a lot of unpredictability. Last 1 year or so has been a classic example about changes which are happening very fast. So from a business perspective, things might, what is good today might not be relevant after 6 months. So how do we address that unpredictability? How can we adapt to that? Second point is the way in which energy has been seen, and then how do we move towards clean energy? So you will see a lot of industry discussions around green energy. Hydrogen is there in the picture. So the next generation, maybe my children, when they purchase cars, they will have a much more easier option to buy clean energy cars. So how are you going to that transition of energy? Evolving production needs, which means that market demands are very, very elastic. Somebody needs small sizes, somebody needs big sizes. So how do we adapt to that? So these were the on the top row. These are the three bigger challenges, and then one is the workforce. Workforce is aging. So how do we adapt to that? In India, it may not be a very big problem, but in many economies, that is coming out to be a very grave problem. How do we adapt to the aging workforce, and how do we adapt to the next generation workforce, which is mobile native, and then driving digital transformation, because there is a lot of computing available right now. So can we computerize some of our systems? Today, most of the systems which we were using 10 years back are now under the umbrella of digital. But while doing that, we also ensure that what was invested 1 decade back, 2 decades back, that is still protected, that is not wasted. So how do we do that? So if you've got a electricity producing plant, so that will not change for maybe 50 years. So how do we make sure that those investments are still relevant? So this is the layout in which the industry has been trying to grapple with. And once we have this, what happens is the industries need to expand with this changing scenario, but they also face unique risks. So most of the systems that we see in a real life plant, those are distributed systems with various types of assets. Assets means you could have your measurement meters, you could have your SCADA systems, you could have specialized equipment. Those by nature are complex. Sometimes all this equipment work in a process which by itself is complex. Okay, manufacturing something would be a process. So how do we ensure that that process complexity is adequately captured and that is not compromised? Many times when you go to any site, one of the most prominent challenges is that People do not know what is there inside. I mean, they would have a list of what was purchased, what was installed, what was commissioned, what was designed maybe 5 years back, but then they do not really know what is actually there in terms of new additions or the state of a current asset. Top of that, the security related awareness is less. It is improving, but it is still less. It is sometimes insufficient, and the security expertise is also insufficient. So when you add all these points together in terms of complexity of the plant by itself, and then limitations in security awareness or limitations in security expertise, what bad actors, the villains, what they see is that, okay, this is lucrative now. If I can crack into that system, then there is some money to be made, and the impact to that factory in charge of the factory owner is not just about production losses. That anyway will be there, but more so about health and safety. If a critical plant is interrupted because of some reason which is not planned for, there could be a health hazard, there could be a safety hazard, there could also be an environmental hazard, there could also be damages in the public domain. So these are the areas in which the operational technology cybersecurity differs from information technology cybersecurity. So, and this can lead to loss of trust of that company. Needless to say, if there is an impact, if there is an incident, then the revenues dip, right? Because it takes time, and you can follow the news almost every day. There is some news in the globe about some company which got hit or which got compromised. So industrial companies compared to a bank or a retail store, industrial companies face unique challenges in terms of health and safety, environmental hazards, public hazards, and massive loss of trust. So this is the environment or the areas in which cybersecurity for industrial companies need to be planned for. And these are some numbers coming from global studies. The India numbers might be a reflection of this. What a recent research says from IBM is that in case of a breach, the total cost, not just the money which is asked for ransom, but there is incidental cost, there are costs for legalities, there is cost for damage control. So all that comes up to closely around $4.5 million US. Okay. In energy and industrial sectors, it is slightly above that average actually. And ransomware has been one of the biggest threats continuously for the past many years, which means some bad actor will try and compromise the system and then demand money to bring it back to the previous state. More often than not, even after paying the money, it doesn't happen. So there are a lot of research going around as to how to tackle that. But by the way, as per the research which is conducted by IBM, it says that more than $800,000 was the average ransomware payout in 2021, and this number has been increasing. There are all types of ransomware operators. It is also available as a service now. So somebody has got an intent but not the toolkit. Then you have got somebody who has got the toolkit. They will give the toolkit, use it, pay whatever charges for that, and exploit the system. So all those business models are also there on the ransomware side, which is not good. 26% of this set also know that even after paying ransom, the data could not be restored, because most probably what happens is once the system is infected, the data is locked in. Data cannot be read or written. So it is also encrypted. So now this data, even after paying money, they do not decrypt and give it back, and that data is again sold to another agency, what you call as dark web or things like that. So it is a serious problem. So it is not just a money problem. So what to do? What the research also says is that typically in 2021, it took about 22 days of recovery time. So if something happens on August 30th, not before September 21st, there is any decent return back to normal. And this average is moving upwards, which means the attacks are getting more and more complex. Interestingly, what it also means is that one statistic is in terms of recovery time, but there is another statistic. If you see bottom right, that it took about in 2023, it took about 277 days to even identify, okay, and contain a data breach, which means it was always there in the system. It only became active on a particular date, and then it created a lot of problems. And then to recover from that, it took 22 days. But it was lying there in the system for about 277 days, trying to snoop in. So all this kind of metrics are being done by companies like IBM, Microsoft. A lot of cybersecurity companies are investing money to find out how do we identify it the earliest. But a cybersecurity incident is something which every company is trying to prevent. These are some of the examples. I will not go through each of them. Right from 2010, when the most familiar OT attack, OT virus, if you say, Stuxnet, which was supported by a certain nation, and then they tried to jam the usage of a particular equipment. So right from there till 2021, where we have got statistics or publicly available information, there have been various kinds of attacks. Believe me, in my role, I come across companies who admit in private that they were hit, but they cannot go public. So these are only the incidents in which the companies themselves came up and provided that information. But it happens almost everywhere, almost on a daily basis, especially in a country like India. So we require a lot of good people to thwart those attacks, to do latest cutting edge research, come up with defense mechanisms. But one common line is that there is a lot of financial losses. There were a lot of health hazards because of that. Many a times it was through ransomware. It could have been an entry from an IT system, which means somebody who is a business user. From there, the infection came in, and then it spread because of lack of proper protection controls. It spread to the factory controls, and then the factories got compromised. You can read about all of these attacks in the public domain. Some are named, some are not so, understandably. What is true is that the nature of attacks and the frequency of attacks both are increasing. This is a site which I like to go to in between. So this is our Indian Cybersecurity Emergency Response Team, CERTIN. This is a very sharp unit. They also have certain units for various sectors in the power ministry. So some of these activities from CERTIN, as per their 2023 annual report, the number of incidents that they handled, number of vulnerable, and CERTIN is also an advisor to various firms. What kind of incidents which took place? So phishing is something which is there. Then somebody's scanning the network, inserting some code. So if you see, I mean, there is no particular way in which it emerges. It can come from anywhere. Okay, so CERTIN tries to monitor at a very large scale. Later in this presentation, we'll also see some of the guidelines coming from CERTIN. But a good site to just go in between and see what is happening in India, because I believe we are doing a lot of things in cybersecurity damage control. Yeah, so this was a brief background about what cybersecurity means, and then what kind of cybersecurity is there in the children. I will also touch a brief bit about what is there in IT and OT cybersecurity. Why it is because we equate cybersecurity with traditional IT cybersecurity in terms of protecting the data, which is true. So if I'm using a bank website, I expect that my data would be protected. So that is data integrity. But in an industrial domain, it is about the process. For example, if I'm a food manufacturer, if my food making recipe is compromised, then that can create adulterated food materials, which can harm people. So I have to be very, very sure that my process is secure, the process integrity is maintained. So the cybersecurity thought process or the perspectives are also different. Traditional IT will also look at data integrity, whereas traditional OT cybersecurity looks into mission critical systems and says that, okay, the process has to be secured at all times, otherwise lives can be lost. This is a very popular way in which the IT and the OT uh, domains are differentiated. So IT domain, whether it is the laptop that I'm using right now, this is a business IT laptop. It has been given by my company. It is not used for any manufacturing process. It is used only for checking my emails, checking my, getting connected to meetings, or creating documents and so on and so forth. So it is part of my information technology stack. So here, confidentiality, integrity, and availability. These are the three main themes which are given priority. But if I was in an ABB factory in some place, then for me the priority would have been availability. That means equipment on which the process has to be performed. That has to be available at all times. It cannot be non-available. So availability, the integrity of that equipment, and last comes the confidential. So it's inverted. The priorities are inverted in when you look from an IT perspective and from an OT perspective. So that's why this gap has been it is always there, but now it is shrinking. A lot of discussions are happening with the IT professionals to ensure that the operational technology systems are also equally protected with the same level of strictness. Some examples are there. I will not go through it right now in terms of deployment guidelines, in terms of patching mechanisms, in terms of solutions which are available from the market. So all these things are taken into consideration when we talk about both the streams, but then the priorities are entirely the opposite. So we'll emphasize more on the red part, which is availability when it comes to operational technology. Uh, the resources, which means the human resources or the computer resources, they tend to be the same in between IT and OT. How do you get them closer? So it differs because the core point is that if a factory goes down, who is responsible? Is it and definitely the factory supervisor plays a highly accountable role. But if the factory computer is compromised, then who is responsible? Is it solely people from the factory side, or should it be people from the IT side who are sitting somewhere else? So this kind of friction is always there. I would call it as a tension. So what we have seen is that with the increasing usage of digital systems, now cybersecurity is coming as a common bond between IT and OT. And this we are seeing on the ground as well. You see a lot of discussions in which, even if it's for an existing plant or an upcoming plant, there is a lot of participation from the business IT side, because the best practices from that domain will also be employed here. Because it's a holistic issue, because a lot of data connectivity is being expected nowadays. What somebody from head office wants to see what is happening at a particular plant or in a particular assembly line. What is the data? So that data needs to be sent back as much in real time as possible. So how do we do that in a secure way? So these are the ways in which business expands. If you recollect, going back to the business drivers, so increased connectivity is there, increased digitalization is there. So cybersecurity is playing as a key role between the IT and the OT teams. And all these things are made possible for the industrial control systems on the three pillars of people, process, and technology. So in an industrial environment, the people are always there. So you would find somebody who is working in a particular area for multiple years. So they may or may not be very cyber savvy. So how do we make them well equipped so that they can understand about the cybersecurity threats and also the actions that they can take? So that level of competency has been built into the operator level. So people are the most, that is a common view across the industry, that people are the ones which have the most important role in protecting a system. Second part is process. What could be the processes which are necessary so that the companies of the organization security strategy is maintained. Third part is the technology part of it. Important, but if you look at the other two, it is relatively lower, because technology keeps on evolving, technology keeps on changing. What we say as cutting edge today, in 3 months' time, it is replaced by something else. But the whole idea is that all these three pillars need to be in sync so that the cybersecurity profile or the cybersecurity maturity is maintained. So we have covered two main themes. One is what is cybersecurity, what kind of cybersecurity varieties are there between IT and OT, the people process technology framework. Now we step into the regulations, and I'm trying to take some time in this discussion because why should we do cybersecurity? I think that is more important. That will also trigger some thoughts about where you can invest your time, when you have to learn and deep dive into forward things. So cybersecurity regulatory landscape and IEC 62443 standards. So these are the 62443 is the de facto standard now for operational technology security, or commonly known as industrial cybersecurity. So what kind of guardrails are there? So I'll just touch a brief bit about 62443. But even before coming to that, there are, if you look at as a whole, in terms of various countries, each country has their own expectations. They have a very broad view of how the regulations should be, to be maintained. So in India, there are the power sector was identified as one of the most critical sectors among the critical sectors. So a lot of regulations came first in power sector, and slowly it will expand into other areas as well. So in that, if you recollect, there is the India Cybersecurity Emergency Response Team, CERTIN. They came up with directives. Then there is something called as CEA, which is the Central Electrical Authority. They came up with guidelines. Now we have got the Reserve Bank of India, stock exchanges. They're coming up with their own set of obligations. And then there is a Data Privacy Act, which was introduced quite recently. So India, I see, is a lot of churn happening, a lot of great thoughts about how to protect our digital ecosystems. So CERTIN says that if there is any incident then which has been captured, then that has to be reported to CERTIN within 6 hours. So, and then while reporting, at least 180 days of information, log information has to be supplied. So this is what CERTIN expects. And believe me, if you're in a plant, if something happens, and to identify that itself is a challenge, and then to transmit that information to CERTIN within 6 hours, all kinds of infrastructure components are required, collecting that logs. So that is a lot of technology components coming with the whole idea to ensure that the plant remains secure. Similarly with CEA guidelines, there are a lot of what they call as articles. There are 14 chapters, 14 articles. They cover topics or details around personal cybersecurity, what kind of capacity is required, what kind of capabilities are required in terms of supply chain, which means if a manufacturing plant has got 30 suppliers, then each of the suppliers, what should be the minimum level of cybersecurity? How do we ensure that that posture is maintained? What kind of policies? In case of an incident, what should be the response? So quite interesting topics. So those who are keen to know more about your students are interested in cybersecurity, I think the Indian power sector related cybersecurity is one of the very great stepping stones to enter into that area. Along with that, if somebody has got inclination towards looking into what Reserve Bank of India or Security Exchange Board of India is trying to do, they also put a financial penalty on some of their operators about in case of a miss, what should be the penalty. So a lot of interesting regulations which are coming up in India. Yeah. So if you look on the right hand side, globally what is happening, there are countries with very large operational technology layouts. So Saudi Arabia is one example that I've taken. Then there is UAE, Europe as another prominent example, and then USA. All of these have got their own national cybersecurity guidelines coming in, each with different levels of detail depending on what sector, what level of history they have, what kind of maturity they have. Europe has also gone ahead and put penalties in case if the regulations are not maintained. USA has got multiple regulations coming up for various sectors. Now this is how the cybersecurity regulations evolved, but then the experts came together and put their heads together and said that okay, there should be a common regulatory framework, and that got approved in the IEC committee, and now that is numbered as IEC 62443 and that is meant only for operational technology cybersecurity. So if any company or technology manufacturer or system integrator says they are aware of 62443, that's a very strong message. That's a very good message, which means that a lot of common things will be taken care of. Even though country guidelines will have their own expectations, anything built on top of IEC 62443 standards will be a good starting point. This is also a good area for some of the student community to look into how to get themselves certified in IEC 62443. There's a very well-established path, move from one level to next level, total 4 levels, 3 examinations. So if they can do that, that would be really good. And we need a lot of such experts in India to step into this role, into this emerging field of IEC 62443 related cybersecurity. I will not go into each of this because this is I mean, in my day job, each of these boxes is a couple of days of workshop and a deep dive meeting. So, but just to make people familiar with what is there in India as well as globally. So 62443, this is in a nutshell what it is. There is got 4 layers, 4 levels. At the bottom most, you've got the component level, which means the security components. In terms of in any, for example, if you've got a microcontroller running or a PLC running, so is that component cyber secure? What are the standards to be followed for that? So that comes under the layer of component cyber security. Then you've got the system cyber security in terms of supervisory controls or any kind of control systems. What kind of cyber security should be expected from a system level? So those kind of requirements are clearly listed out there. What kind of responsibility should be there on the technology OEM? What kind of responsibility should be there on the factory owner? What kind of responsibility should be there for somebody who's an operator? All those things are clearly listed out. And then the green layer, which is the policies and procedures, some prescriptive guidelines about how that cybersecurity can be implemented, some guidelines around that. And the topmost layer is about putting the concept whole together, how to run a program for cybersecurity, for OT cybersecurity following IEC 62443. Each of these boxes has got various sections around that, and I think it's a good way for students to get themselves certified so that they can be part of this emerging field and take up one of those boxes and deep dive into that. So now this is something which I spend a lot of time with my customers in terms of what is security level, by instance. So as per, and there are various definitions, but the most popular one, the one which is commonly agreed, is the IEC 62443 security levels, which is a measure of the maturity of an organization. So starting from the leftmost, which is the security level 1, SL1, going up to SL4, the highest level of cybersecurity, as per today's classification. So security level 1, what does it mean? It means that if there is a breach by mistake or unintentional, somebody Sanjeev, for instance, has got a very weak password. I put Sanjeev 123 as my password. So, but do we have? I mean, even though it is not expected, I'm using such kind of password. So and the system's got compromised. So that is unintentional. Somebody anticipated my password, entered into my system, and created some damage. But do we have protections against such kind of attacks? So that is where SL1 maturity comes in. So any protection against unintentional breach of security. Okay. So for example, a network engineer is troubleshooting something and accidentally see some passwords which are being exchanged, and they can make use of that, even though it was not expected or not intentional. That is a vulnerability. Security level 2, which is the level of protection that makes slightly harder for a more aware attacker. We call them as hobbyist attackers. Those have got some kind of scripts. They have got good programming background. They might not necessarily be having a very bad intent, but curious to break into a system and then create some damage into that. So security level 2 is the level of protection that any organization has to defend against such kind of attacks or to identify such kind of deficiencies. SL3 and SL4 are where the security level is at a higher stage, because the levels of protections are also high, because the attackers have got different motivations. They've got different levels of sophistication. They've got huge resources, and they also have the waiting game. As we saw in the earlier slide, they could be waiting for months or years before making an attack, because that much resources are available for them. So and most of them are professional hackers. So SL3 and SL4 are quite ambitious for a factory to reach there. It takes a lot of time, especially for SL4, which is where there is a lot of support coming from nation state. So it could be a country sponsored attack. So makes it very difficult to identify or to defend. But then do we have such kind of protections? And if so, then you are at SL4. Now each of the steps is a journey by itself. It takes about 3 to 4 years for a decent company to move from one level to another level, keeping in mind the people part, the process part, and the technology part. So we in India, we are seeing a lot of energetic discussions around this. My professional view is that if someone is at SL2, that's a very good point. So SL2 means that a lot of basic things are taken care of. SL3 could be a slightly challenging journey, but even at SL2, companies can say that they're relatively safe if they do the minimum basic cybersecurity things consistently. So just a glimpse into what this is, and as you can anticipate, a lot of research going into these areas. Cybersecurity researchers can choose to be in what level of research they want to focus upon. The student community can take it forward. So when we talk about cybersecurity, it is not just security, the red dot by itself. There is a lot of emphasis on governance. What who should see the problem? Is it only somebody in front of the screen, or is it the supervisor of that plant, or is it even at a higher level? So, and then what should be the governance layer for that? Who should take the decisions? Who should approve budgets? So that is where the governance models come in. And then there is compliance. As you have seen, there are a lot of national compliance expectations. And in today's world, a company which is set up in India would be exporting to 3 different countries, which will have their own cybersecurity guidelines. So how do we comply to all of them? Because if there is any breach, then those local laws will take priority. How do we remain compliant? So security is in a triage right now with governance and compliance. Under governance, you will see that the highest levels of management, they are involved, and of course with participation from the IT side, the experts coming from the IT side, as well as experts coming from the OT, the operational technology side, those who run the plants. And all this is quantified under risk management. So a cyber risk is now increasingly listed under the company risks. And if you see some of the shareholder reports, or if you happen to be reading a company report, you'll see mention about cyber risks into the annual report of that company. We spoke about compliance, whether it is national guidelines or guidelines coming from the industry, for example, power sector, or automotive sector, or oil and gas sector, or pharmaceutical sector. Each sector will have their own industry standards. There would also be company guidelines. So, for example, like a large company like Reliance has got their own guidelines. A large group like Tata, they have their own company guidelines. So all this come into play, and depending on the business scenario, they will take precedence. And as you would anticipate, this is all based on cyber physical systems. There is nothing called as disconnected systems now. All are cyber physical systems. And since business is scalable, the systems are also scalable. So security should also be scalable. Now, all this is laid out on a foundation, strong foundation of a defensible architecture. So you could have an architecture which was used to set up a plant in a point of time, but then is it scalable? Is it really defensible? How did that architecture evolve? So that is a very interesting topic, where we see a lot of emphasis when we talk about cybersecurity investments, about what is the architecture, how robust that architecture is. Yeah. So with that background, we see the skills. When there is a research report which was published recently by DSA, the Data Security Council of India, they took some time to find out what should be what are the skills which are in demand. So this is a snippet of that extended report. What it says is that at present, there is a lot of demand for information security. So people in business security roles, uh, or application security. So ensuring that the browser is working safe, the word applications are running safe, the banking application is running safe, the ticketing application is running safe. So a lot of emphasis on application security at present, and a lot of emphasis on tools. So different kinds of tools, whether it is proprietary or open source, tool expertise is given a lot of emphasis nowadays. And knowledge of cybersecurity fundamentals, network fundamentals, operating system fundamentals, web fundamentals, all these are expected in today's domain for a person who is into a security role, technical security role. All these points come into play. But the report takes a peek ahead and says, okay, what will happen in 5 years' time? So if you see, artificial intelligence is right on top, followed by data forensics and incident response. So the cyber attack of today's world is not necessarily coming from a human, what is it, human operator. It is coming through some computerized systems, weaponized systems, which are running on AI algorithms. So how do we identify such kind of attacks? What kind of forensics uh, need to be looked into? What should be the response in case of such kind of an incident? So that's the next level of knowledge which is required from the upcoming talent. Wireless networks, a lot of communication nowadays is turning wireless. So how do we ensure that those wireless networks remain protected? Are there ways in which we can ethically hack them and make them more stronger? Obviously, cloud security plays a big role. And compliance. We saw compliance as a very big driver, and knowledge of regulations is paramount nowadays. So in the next 5 years, a lot of jobs or experts are needed in that area, and auditing of security processes. That is today also it's a big field, but it is expected to become even more in demand in the next 5 years. The report is also very interesting in the sense that even though it starts with an emphasis on the technology part of it, but it slowly shifts to the people side. And along with cybersecurity, you also require a lot of soft skills. And I'll tell you why, because if you see in movies, we see computer operators who are using keyboard shortcuts and trying to either attack or trying to defend. But if you try to explain what is happening, they may or may not be the best persons to do that. So in a field like cybersecurity, especially with industrial cybersecurity, where there are various stakeholders, we require people with soft skills who can explain, who can understand, who can translate information and take it forward. So maybe it is not very clear on this slide. Let me try to make it better, but I don't know if it worked. Yeah. So a lot of interactions are required across the stakeholder spectrum. And that is where we see a lot of demand to emerge in terms of problem solving skills, presentation skills, interactions with clients or customers, having the business acumen to understand the impact of an incident or where to make those investments, adaptability, flexibility, all those points come into play. So this is something which I thought might be useful when you interact with the student community about where can they focus next. Not all the roles in cybersecurity need to be technology focused. There are a lot of scope also for people who can understand technology, make it easier for the decision makers, and make it easier for the systems to remain protected. So soft skills will be in huge demand. So having seen that part of cybersecurity in terms of how it was, what kind of systems were there, what is IT security, what is OT security, looking in briefly into what kind of regulations are there. It's a very big field, but so we just had a one-page look at that, and then looking into what kind of skills would be required in the near future. I go into my next segment, which is ABB's portfolio of what we do. Some of these things might be familiar to you, or some of these might be too you would have experienced that, or you would have used that in your own world. But this is something that we do it for our industrial customers. It is based on four pillars, I would say. One is the foundational security, so things like antivirus mechanisms, the appropriate patches into that system, having appropriate backups. Even though it might seem very simplistic, Many companies still don't do that or don't do that regularly. So foundational security is something which is of immense importance, and we provide those services around that. Then there is security services. Our engineers go to to site and ensure that the systems are well maintained. Security operations is an area in which monitoring of plant information to ensure that no incidents are no taking place, and all this is based on the security blueprint, which is also called as the architecture. So if you see, it starts with a step called as assess, which means assessment. So assessing what is there at site, that itself is a skill. It's a very specialized skill. It is an area in which there is a lot of certification which is happening. Students who are interested can explore this area in which how to understand the risk, how to quantify a risk, how to assess that risk. A lot of companies which require experts who can go to site and do it. It's a mix of an office job and a site job, quite interesting. But so assessment of what is the current cybersecurity profile. Once we have that, then there is the consultancy part of it. So how do we plan the next steps? Who does what? So that is something that comes under consultancy. And then the implementation phase comes in. So how do we implement some of those controls? So we mentioned some examples. The red colored ones, these are the foundational controls. So malware protection, security updates, backup, hardening of a system. So ensuring that those ports which are not required are never used. Only validated users are using that system. Only validated applications and services are running on that system. All that comes under system hardening. There's a lot of research going on into those areas as well, in terms of how do we have the next level of controls in the age of AI. Asset inventory. Asset here means anything which can be connected to the network. So can we have a real-time inventory of all those assets, ensuring that there are no suspicious or malicious assets which are introduced. Application allow listing is the way in which we ensure that only necessary applications are running on that system. So each of these areas is a topic by itself for interested students to step into. We also expect the course curriculum to touch upon these topics as to how security can be enhanced into various systems, how security can be maintained, how vulnerabilities can be detected, how systems can be monitored in real time, and then what kind of actions can be taken. There is a lot of I would say technology research happening in the area of security monitoring and security operations, because of the sheer size of attacks which are happening. The attack points are in billions. So to monitor such kind of events, it requires a lot of cutting edge technology. And then once it has been identified, what kind of steps to be taken in near real time. So the operations need to be taken care of. So and you will have various limitations of the human operators. Sometimes the site is far away. It requires a system to be utilized. So a lot of research which is happening in those areas to identify and also to take appropriate responses. All this to ensure that the risk profile remains low. So there will always be some risk, but how do we keep it low? So this is what ABB does for our customers. This is where we also invest a lot of R&D, and we are also working closely with several universities globally to ensure that the cream of knowledge comes to or works on these areas in which there is a lot of demand. What we do is also in terms of security framework, there is something called as secure by design. So while building itself, we ensure that security is taken care of. It is part of each and every step in that process. It is not plugged in after the product is made. It is made right at the beginning, along with the journey of the product development. So this is a huge area of exploration. How do we have a secure by design? Then secure by default, which means that at the time of usage, the default installation procedures were enforced, and the attack surface is minimized. Then secure and deployment, so which means that when the project is actually commissioned at site, then the appropriate cybersecurity measures were taken into consideration, and any third-party software or solutions are properly validated. So These are the three tenets of our security framework to ensure that our systems work as expected, and it is as far removed away from threats as possible. There will always be some threat, but then can be at the minimum, attack surface. I thought for today's topic, this is something where I am trying to invest some time myself to find out what more can be done. So, secure development lifecycle. This is an area in which a lot of not just software. This could be for hardware as well, and cyber physical systems. So, is security taken care of? So, here a lot of emphasis on encryption, cryptography, what kind of key mechanisms we have. Then it moves into the reference architecture. A lot of expertise is required in this area in the near future about what kind of architectures based on 62443 can help customers who have got manufacturing bases, end-to-end operations in terms of development security operations, right from R&D to field. So if there is something which is being developed in an R&D facility, then ensuring that it is securely developed and operationalized and used in the field. That's an emerging area of. There is already some research, but then a lot of emphasis is being laid into DevSecOps. One area which is Indian government is also coming out with a lot of leading material is that around software bill of materials. So if you're interested, you can see the certain guidance around that software bill of materials. In the currently, if an equipment is made, it can be having tons of materials which have come from various vendors. There is no end-to-end traceability. So the software bill of materials is an emerging standard as well as an emerging campaign to ensure that end-to-end traceability is maintained, because, and especially India is a leading player in that initiative, because the kind of geopolitical situation we are in, we are also importing a lot of materials. So can we have traceability to who has developed that particular piece, and then can we, in case of a problem, can we trace back to that source? So software bill of materials, or SBOM, is a emerging area. Anybody interested can look into that. I am hoping that this also comes into part of some research curriculum. Digital certificates been there for quite some time. It is again evolving, especially in terms of the emergence of AI and cloud security. Data contextualization. Not every incident can be easily understood, so it has to be properly contextualized for which sector, for which equipment. All that information has to be laid in so that the security experts who are sitting at different levels, they get the right information. So OT cybersecurity data contextualization is a key area. And then you have got things like using containers to say that software containers, so that the products and services, as and when required, only that particular service can be created and deployed. So, and then this entire cyber defense tool chain, detection, monitoring, response, all these things can be properly orchestrated at scale. So these are some of the areas where not just software, it's a mix of software, hardware, mix of design. So hopefully sessions like this we can explore more on each of these points and take it forward, so that we all benefit from that. So it's a mix of security as well as data, and these are some of those areas which I am trying to learn myself, and what we can do. So I think I'll leave with in the interest of time a quick view of what we call as a reference architecture. So this is a blueprint for each and every business scenario. This needs to be adapted. And this is meant for industrial systems. Anybody who is interested in IEC 62443 can step into this world. It is aligned to 62443 standards. This is a layout of a architectural view of a plant network. So if you just magnify it, it helps. Yeah. So if you read from level 0 onwards, where is the process which runs in. So it could be any kind of process. Your sensors are here, your equipment is here. It could be automotive domain, it could be a field site. It could be, various kinds of industries. So you've got all your sensing equipment here. Then the control logic comes here. In terms of a control network, there are various protocols. You can ignore this the cybersecurity controls for the moment, firewalls and protocol converters and all. The idea is that data flows from the control layer to the supervisory layer, where you've got various decision-making systems in place. This could be your operator workplaces, uh, engineering workstations, things like that, where the real work is configured here. And now you've got the cybersecurity pieces coming in this layer, which keep the system protected, whether it is in terms of security patches, domain controllers, backups. And what ABB has done is zoom out. What we have done is we have, and these are called as level 0, level 1, level 2, level 3. Level 3 is what you also hear very frequently in cybersecurity discussions, called as demilitarized zone. So we have gone a step forward and classified that into two parts. One is the right hand side, which is the system management layer, and on the left hand side is the operations management layer. And we have taken this conscious choice to keep the cybersecurity systems logically separate from the business systems, so that in case of any expansion, the business systems and the cybersecurity systems need not be dependent on each other. So you can have more security controls added here. So if you see uh, on the system management layer, you will see the mechanisms in which remote access can be controlled, or patches can be distributed, antivirus can be supplied, backups can be taken, or file transfer mechanisms can be done, or if data has to be exchanged with some external party, that can be done. And then there are other tools which help in monitoring and detecting, which can also be kept in this layer, logical layer. Whereas on the business side, you will have the historians, you will have application servers trying to find out if there is any kind of middle layer decision making systems to be done from a business level. So all these things are logically segregated, controlled through firewalls, and then the mail systems and various other clients, could be billing systems, could be inventory management systems, which are on the office network, and then they could be in turn connected to various cloud control systems, which will give various levels of data. So this is a logical view of a industrial cybersecurity architecture. Uh, each of these components is a discussion point by itself, and I would expect industry also, or sorry, the academy also to to familiarize the students with such kind of approaches, so that students who are willing to, or who are researching in cybersecurity, can be familiar with network cybersecurity components, can be familiar with standards, so that we get much more ready experts who can plunge into this beautiful world of industrial cybersecurity. So this is one particular view. You can have various views, but this is the ABB interpretation of a reference architecture. So I will leave with just three thoughts. One is for cybersecurity at an industrial scale, one is to have the defensible architecture. We saw one example of that, so that the communication between devices, between zones, and between various levels, those can be easily channeled, easily maintained, easily protected, and then deploy the foundational controls. And each of these foundational controls, whether it is antivirus, whether it is patch management, there's a lot of work which happens in the background, a lot of possibilities for new research to come in there. A lot of emphasis on behavioral research about how do you identify any problems in that layer, and then monitor for any kind of malicious activity. So monitoring by itself is a very strong subject. How do we monitor large systems? How do we identify any kind of cybersecurity threats? What steps need to be taken? So the key message is that to have a defensible and scalable architecture, deploy the necessary controls, and then keep on monitoring. So that takes care of a huge chunk of the workload for cybersecurity. So I will take a pause here, and in the interest of time, and see if there are any thoughts, any questions. Otherwise, I'm good at the end of my slide. Any questions? Any thoughts that? Hello.
Yes, sir.
Yeah. I was not looking at my screen, so if there are any comments, you can share it now, or if there are any thoughts, anybody wants to ask or tell something available.
Okay, thank you so much, sir, for your session. On the behalf of the Sri Barasaheb Mani Shikshan Prasarak Mandas, Ashukramani group of institutions, I take this opportunity to express a heartfelt gratitude to extend a heartfelt gratitude to Mr. Sanjeev Sharma for sharing his deep expertise on cybersecurity for critical infrastructure protection. With over 2 decades of experience in technology, digital solutions, and OT cybersecurity, Mr. Sharma provided us with the invaluable insights into safeguarding critical infrastructure in today's interconnected world. His explanation of bridging operational technology and information technology to build the resilient cybersecurity strategies was both timely and enlightening. We appreciate his guidance on compliance with international standards like IEC 62443 and national security frameworks, which are essential for maintaining robust defense systems. Thank you, Mr. Samasa, for your engaging presentation and for addressing our queries with clarity and depth. With this, we once again thank you, sir, for your valuable contribution, and we look forward to many more fruitful interactions with you in future.
Thank you. So there is one question from Mr. Joshi.
Yes.
I read that in the fast advent of AI tools, how strong the current cybersecurity tools are. Oh, that's a good one, because yeah. So what view I have is that today we are in this era of, in the last few years, we are using a lot of cybersecurity controls to monitor and collect data. So if you see our phones, our laptops, they are quite secure. But if you look into the industrial cybersecurity zone, it is still work in progress. So a lot of controls are getting added, and we are collecting data. Based on that data, there is a lot of database decision making, a lot of AI processing, and the tools will evolve. So in the nature of your question, there are a lot of AI tools which are unfortunately used for cracking, used for hacking. Uh, the protection-based AI tools are still, work in progress across the industry spectrum. So, and there's a good strong reason for that. If you recollect the people process technology part of it, the people need to be made aware of first, and the right processes should be there, and then the tools. We cannot have a very super intelligent AI tool, but then the people do not know what to do. So my personal view is that the AI based defense mechanisms are starting to emerge. There are a lot of things which can be. I mean, next week I'm actually, if anybody is in Delhi, you can attend my session. I've got a session in Delhi next Friday, sorry, where we show a little bit demo of what our systems do. So I call that as the first or second iteration of the AI-based tools, because it can sense if there is a problem. But then how strong they are in terms of uh, emerging tools on the other side, I think it's there is still a gap. But with these kind of programs, with kind of the industry academia collaboration, a lot of research goes in the right areas, and I believe that once the data has been properly collected and aggregated, our base of AI enabled defensive tools will become even more stronger. Currently it is only industries which are, or companies like ABB, which are trying to invest a lot, but I expect uh, that with a lot of academic participation, then we can have right research going in. So a very well mentioned point. So AI tools, there are a lot of tools, but these are also, I would say, piecemeal tools. The entire system of AI tooling is still few years away because of regulations, because of how people can use that technology. Okay, yeah. So the Delhi session is yeah, it is a bit of a closed loop session. So I'll see, but hopefully we can meet in person sometime. And then thanks to Professor Ajay Deshmukh, he keeps on egging me to come and meet some of you, and then we can have that session. So Thanks for the question. I think I hope my comments made some sense.
Yes, sir, definitely. Thank you so much for your session, sir. It was really good.
Thank
And okay.
Thank
Uh,
you.
there
Yeah.
is one announcement for participants. Actually,
Mhm.
we'll start our next session at sharp 5:15. So you will having the break of almost half year. After 15 minutes, you can join, sir. Everyone, all the participants, at 5:15 you can join. Every participants.
Thank you.
Okay. Thank you
I
so
will-
much, sir, again.
Thank you. Thank you. Thank you.
Okay.
Namaste.
Hello? Hello?
Yes, sir.
Uh, our next resource person will join within 10 minutes. Please be
So
online.
madam has told at 5:15, sir.
Okay, okay. Okay, then she will join.
Okay.
Okay. Just be on online in the meeting.
Yes, sir. Yes, sir.
Okay. Thank you.
Hello, Shreya ma'am.
Hello.
Shreya ma'am,
Yes,
we'll start
ma'am. Huh,
our
ma'am.
session.
Sorry, ma'am, could not hear you.
We'll start our session.
Okay, ma'am. Okay.
Okay.
Good evening, everyone. Now we are moving towards our next section. We are lucky to have Dr. Seema Patil, ma'am, on the section number 13 about the roadmap for implementing Industry 4.0 in Indian manufacturing. It's my honor to introduce a distinguished academician, researcher, mentor, Dr. Seema Suhas Patil, ma'am, Associate Professor and Dean Academics at Ashokramane Group of Institutions, Vathar. Dr. Patil holds PhD in Electronics Engineering from Shivaji University, Kolhapur, and brings with her impressive 19 years of teaching experience across the reputed institutions. She has served in a various academic and leadership roles, including lecturer, assistant professor, and currently associate professor, demonstrating her unwavering commitment to quality education and academic excellence. Her areas of specialization includes machine learning, computer vision, embedded system, image processing, and mechatronics. She is a proficient in programming languages like C, CPP, and Python, and simulation tools such as MATLAB, LabVIEW, and Proteus VSM. Dr. Patil has made significant contributions to research with 31 publications in reputed international and conferences. She holds a multiple patents, including a utility patent and a design patent granted by Government of India. Notably, her work on a variable rate spraying systems and autonomous agriculture devices has been well recognized for its societal impact and technological innovations. A recognized PhD supervisor at Dr. Babasaheb Ambedkar Technological University, Lonere, she is actively mentors postgraduate scholars and undergraduate students. She is also certified LabVIEW associate developer and has published a book on a wireless communication. Dr. Patil's contribution extend beyond academic. She has been an active reviewer for Scopus Index journals, IEEE conferences, and has delivered numerous expert lectures and seminars. Her dedication to teaching and research is further reflected in participation in over 30 workshops and FDPs on cutting-edge technologies and pedagogical practices. A commitment academic leader, she has held several key positions such as NBA coordinator, IQAC coordinator, project coordinator, admission counseling cell in charge at Ashokramane Group of Institutions. She has also been instrumental in curriculum development and gate training initiatives. With a strong inclination towards social and outreach activities, she has delivered motivational and awareness talks to schools, college students, aiming to guide them in their educational and career pursuits. Dr. Seema Patil Man stands as a role model in engineering education fraternity, embodying the spirit of the continuous learning, innovations, and societal commitment. Please join me in welcoming Dr. Seema Suhas Patil, ma'am. We welcome you, ma'am.
Thank you, ma'am. Thank you very much. So first of all, I will share my screen.
Yes, ma'am.
So is it visible, ma'am?
Not yet, ma'am.
See once again.
Not
Just-
yet, actually.
Okay, once again I will do.
Yes, ma'am. Yes, ma'am. Now it is visible.
It is visible, na?
Yes, ma'am.
Please wait. Okay, is it visible, ma'am?
Yes, ma'am. Yes.
Okay. Now it is visible or not?
Yes. 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 Visible, ma'am.
Okay, just a minute. Huh? Just a minute.
Huh.
Okay, before proceeding, I will just. Okay.
Visible, ma'am, visible.
Okay. So is it visible now? Okay.
Yes, yes,
Visible, ma'am.
visible.
Just
Visible
see the
words.
presentation mode.
That's a quote, man.
Okay. Now just see whether it is okay.
Yes,
Perfect,
visible.
ma'am.
Yes,
No
ma'am.
problem. Yes.
Okay.
Yes.
Full screen.
So,
No
Okay.
problem.
yes. So good evening. Good evening, everyone. It is indeed a privilege to be here today as a part of AICTE Training and Learning Faculty Development Program 25-26 on Next Generation Manufacturing Embracing Industry 4.0. First, I extend my warm greetings to all the participants, organizers, and experts, fellow experts contributing to this significant initiative. See, Industry 4.0 is not just a trend. It is a transformative journey that defines the future of manufacturing and reshapes how we design, produce, and deliver products. So my topic name is Roadmap for Implementing Industry 4.0 in Indian Manufacturing. See, this is very crucial topic. It is timely and crucial topic. Okay, so in this session, we'll explore the key pillars of Industry 4.0, challenges faced by Indian manufacturers, government initiatives and policies, step-by-step implementation of this roadmap for implementing Industry 4.0 in Indian manufacturing. And for that, the role of academia and research organizations or institutions we'll see in this particular lecture. So why this roadmap is important? Why the name of topic is roadmap? So this roadmap is nothing but what? It is a structured approach which ensures scalability, cost effectiveness, and long-term sustainability. Okay. See, Industry 4.0 is not merely about automation. It is about creating a smart, sustainable, and competitive manufacturing ecosystems that can propel India into global forefront. So we'll go to first slide. See, before we move into the roadmap and implementation strategies, it is important that we develop a clear understanding of what Industry 4.0 actually means. See, this Industry 4.0 represents fourth industrial revolution, and it is transforming the way the manufacturing is carried out. Unlike the previous industrial revolutions that were driven by mechanization, electricity, and computerization, this is one about digital transformation and intelligent connectivity. It is a major transformation in how goods are manufactured. This revolution is powered by integration of advanced digital technologies. So what are these advanced digital technologies? In that, we can think of Internet of Things, means IoT, then artificial intelligence, big data analytics, robotics, cloud computing into all this Industry 4.0. See, what makes Industry 4.0 truly revolutionary is that it does not just improve existing processes, it completely redefines them. It connects machines, systems, and people into unified, highly automated, and data-driven ecosystem. See, this integration of all these technologies allows industries to move from reactive to predictive operations, improve the quality operations, reduce downtime, optimize resource usage, and ultimately create a smarter, more efficient, and sustainable manufacturing environment. So to truly understand the essence of Industry 4.0, we need to look at the technologies that power vision. See, Industry 4.0 integrates a range of advanced technologies such as Internet of Things, just now I have said, artificial intelligence, robotics, big data analytics, then CPS means cyber physical systems into manufacturing operations. See, here machines and systems are not just tools. They can communicate with each other, sense their surroundings, analyze information, and make decisions in real time. So to put it simply, we can say that we are now giving machines the ability to see, means machines can see through sensors and computer vision. Machines can hear. Machines can hear through connected devices and smart interfaces. Machine can think through artificial intelligence and machine learning. This marks a fundamental shift in manufacturing, means machines are no longer just executing instructions, they are actively participating in decision making and optimizing operations autonomously. Okay, so this is the image of Industry 4.0 with its key pillars. See here, at the heart of Industry 4.0, there are 9 fundamental pillars. So what are that? First is autonomous robot. So autonomous robot means what? These machines are capable of performing tasks with minimal human interventions, enhancing precision, productivity, and safety. Second pillar is simulation. Simulation means what? Digital twins and simulation helps industries to test and optimize processes before actual implementation, which save both cost and time. Then another key pillars are system integration, Internet of Things, cyber security, cloud computing is there, additive manufacturing is there, augmented reality is there, big data analytics is there. So all these 9 pillars which are there, together, these technologies are reshaping manufacturing, healthcare, agriculture, transportation, and almost every sector of human activity. So this Industry 4.0 is not only about machines and technology. It is about people, innovation, and adaptability. Okay. So this is then what is Industry 4.0? Globally, countries are making strategic investments to strengthen their manufacturing ecosystems. Germany, if we consider the countries as Germany, China, United States, then in Germany, what is there? See, in this Germany, through its Industry 4.0 program, it has been a pioneer in smart factory initiatives. Integrating automation, IoT, advanced robotics is there in their industrial base. In China, through its Made in China 2025 mission, means in China, there is a mission. The name of that mission is Made in China 2025. Under that mission, China has placed strong emphasis on digital manufacturing and innovation-driven growth. If we consider the example of United States, then the United States is also at the forefront, developing advanced manufacturing hubs. And these hubs are powered by what? Powered by artificial intelligence, robotics, big data and analytics, ensuring global leadership in smart production. According to PwC, this is the data given by PwC, global investment in Industry 4.0 are projected to cross $1.5 trillion by 2030. Means see, there is a huge opportunity of manpower also. Industry 4.0 is growing very fastly. It is having big future. Okay. So this strategy, staggering figures means this, according to PwC, investments are expected to cross $1.5 trillion by 2030. So this staggering figure highlights how rapidly the world is moving towards digitally connected, intelligent, and sustainable manufacturing ecosystems. As academicians, researchers, and professionals, we must ask ourselves that where do we stand in this global transformation? How can we prepare our industries, our institutions, our workforce to participate meaningfully in this revolution? And the answer lies in building a strong ecosystem that combines education, research, and industry collaboration. Okay. In the Indian context, manufacturing currently contributes only 17% to our GDP. Under this Government of India's flagship initiative, the name of that initiative is Make in India. So the ambitious target is to increase this contribution to 25% by 2025. Now the rate is 17%. And the target is to 25%, 25% by 2025. So achieving this goal will not only strengthen our economy, but also position India as a global hub for advanced manufacturing. The potential is very enormous. According to India Brand Equity Foundation, they have also given the report. The India's manufacturing market size is projected to reach $1 trillion by 2030. So this makes India one of the fastest growing manufacturing destination in the world. Today, the manufacturing employs around 27 million people in the formal workforce. And with the adoption of advanced technologies like automation, robotics, artificial intelligence, and IoT, we have the potential to add millions of new jobs while also upgrading the skills of our existing workforce. But however, to realize this vision, India must embrace technology-led growth. That is, Industry 4.0 offers us these tools. The challenge before us is twofold: scaling up manufacturing output while ensuring skill development to match the needs of digital economy. So this is Indian context. Okay, this vision can be achievable by strong enablers. So what are the strong enablers of Industry 4.0 adoption in India? So the strong enablers are, first one is the government initiatives like Samarth Udyog Bharat 4.0 and production linked incentives. These are the schemes. Okay, these are directly promoting smart manufacturing processes. The rollout of 5G network, all we know, the 5G network, the rollout of 5G networks, the development of industrial corridors, and the rapid growth of data centers are strengthening India's digital infrastructure. At the same time, the India's vibrant startup ecosystem is creating affordable AI, IoT, and AI solutions, which are particularly beneficial for small scale and medium enterprises. So these small scale and medium enterprises, these SMEs which are there, that ensures that India is not only preparing for the fourth industrial revolution, but is also building a globally competitive, digitally connected, and innovation-driven manufacturing ecosystem. However, the journey ahead requires a strong focus on skill development, R&D investment, and collaboration between academia, industry, and government. So by embracing this transformation, we can achieve inclusive growth, generate large-scale employment, and make India a true global hub for smart and sustainable manufacturing. So the next slide is, for this Industry 4.0, we need to know what the significant challenges are there in Indian manufacturing sector. So while India has immense potential in the manufacturing sector, it is equally important to acknowledge the significant challenges that stand in the way of Industry 4.0 adoption. So to begin with this, the productivity per worker in India is 3 to 4 times lower than that of China. This productivity gap directly impacts our global competitiveness. Secondly, many factories continue to struggle with quality inconsistencies due to heavy reliance on manual processes. So without automation and digital integration, uniform quality standards remain difficult. Another pressing issue is the downtime from equipment breakdowns, which remains considerably high. Unfortunately, only a small fraction of organizations are using real-time data and predictive analysis to address these challenges and improve efficiency. Finally, the skill gap is perhaps the most critical concern. Studies indicate that nearly 70% of shop floor workers require reskilling or upskilling in digital technologies to adapt the demands of Industry 4.0. So without bridging this gap, the adoption of smart manufacturing will be slow and uneven. So these challenges highlight the urgent need for investment in technology, workforce training, and digital infrastructure. If we address these challenges, strategically, then India can overcome these barriers and fully unlock the potential of Industry 4.0 to transform its manufacturing sector. As we have seen, the Indian manufacturing sector faces several critical challenges. If these are not addressed in time, our manufacturer risk they will lose the global competitiveness. And this could lead to higher production costs, longer delivery timeliness, and reduced export potential, which ultimately slow down our economic growth. But there is also a brighter side. Means what? If we embrace Industry 4.0 strategically, the benefits could be very transformative. Means there will be higher productivity, improved quality, and significant cost reductions, and deeper integration into global value chains. In other words, we can say that the same challenges that appear as obstacles today can become opportunities for innovation and growth tomorrow. It is important to remember that Industry 4.0 is not simply about purchasing new machines or software. It is about creating a connected, intelligent manufacturing ecosystem where humans, machines, and data work together in harmony to deliver efficiency, consistency, and value. So, industrial evolution timeline is to truly understand Industry 4.0. It is important that we first take a brief look at how industries have evolved over the past 2.5 centuries. So, evolution timeline. So, to understand Industry 4.0, it is very important to first look at how industries have evolved. Okay, so let us begin our journey of industrial evolution with the first industrial revolution, or we can call that as the Industry 1.0, which started in the late 18th century. So Industry 1.0 means what? This was the era when invention of steam engines and mechanized production completely transformed industries. Okay, until then, the humans and animals' muscle power were the main sources of labor. But with the mechanization, the manual work started being replaced by machines. One of the most remarkable innovations of this period was the steam-powered locomotive, which revolutionized the movement of goods and people. For the first time in India's history, industries scale production and distribute products very efficiently over long distances. In short, we can say that Industry 1.0 was the phase where human muscle power was first supplemented by mechanical power. It laid the foundation for modern industrial society, setting the stage for further revolutions in manufacturing. As we move forward in the industrial timeline, the second industrial revolution or Industry 2.0 took shape in the late 19th to early 20th century. And this revolution was driven by introduction of electric power, assembly lines, and mass production techniques. See, unlike Industry 1.0, where machines relied heavily on steam engines, the factories in Industry 2.0 operated machines with electricity, and because of that, production get faster, more efficient, and scalable. So this was the period when large-scale manufacturing really took off. Industries began producing cars, appliances, and consumer goods in massive volume, making products more affordable and accessible to people worldwide. I would like to tell that one of the most iconic example of this era was Henry Ford's assembly line for automobile manufacturing. By introducing assembly line production, the Ford in their industries reduced the time taken to build a car from nearly 20 hours to just 2 hours and 30 minutes. So this breakthrough revolutionized not only the automobile industry, but also manufacturing processes across the globe. In short, we can say that Industry 2.0 was the revolution that made mass production possible, which increased the economic growth and in the age of consumer society. Next one is Industry 3.0. So moving ahead, the third industrial revolution, or we can say Industry 3.0, began in the late 20th century around the 1970s. This revolution was powered by the introduction of electronics, computing, programmable logic controllers, means PLCs, into manufacturing. For the first time, industries were able to integrate digital technologies into their production systems. With automation, many human operations were replaced by computer controlled machine, which brought significant improvements in accuracy, efficiency, and consistency. Another key development was the rise of robotic on assembly lines, which took over labor-intensive and repetitive tasks. So this robotic on assembly lines, this development enabled the industries to achieve continuous 24/7 production with minimum interruptions. Most importantly, this era marked the beginning of digital manufacturing. In short, if we say Industry 3.0 laid the foundation for the digital age of manufacturing, paving the way for connected and intelligent systems that we now associated with Industry 4.0. And now we arrive at Industry 4.0, the current phase of industrial evolution in 21st century. What makes this revolution unique is the merging of physical and digital worlds through cyber physical systems. So machines today are not just automated. They are connected, intelligent, and capable of making decisions using real-time data from sensors and advanced analytics. So technologies like Internet of Things that connect devices across the factory floor, while the artificial intelligence algorithm predict equipment failures even before they occur. You see, cloud platforms are also there. The cloud platforms enables us to store and process massive volume of production data. And the collaborative work by robots works safely alongside the human in shared workplaces. See, this outcome of this transformation is the rise of smart factories. It is about creating a fully connected and intelligent manufacturing ecosystem where we can say the humans, machines, and data collaborate intensively to redefine the future of industry. So this is all about Industry 4.0. This diagram shows the evolution of Industry 4.0 up to Industry 4.0. Okay. But my question is, why Industry 4.0 now? So what is the importance of Industry 4.0? See, in today's interconnected world, the Indian manufacturing companies are no longer competing only with domestic players. They are competing with manufacturers in Germany, China, USA, Japan, and other advanced economies that have already implemented Industry 4.0 technologies at scale. These countries are producing very higher quality goods at faster speed and with far lower defect rates. Means defect rates are very low in their goods. So, for example, you can take the example of Germany's automotive sector. By using predictive maintenance and AI-driven quality control, they are able to meet global quality standards effortlessly which ensures the reliability and efficiency. On the other hand, without these tools, if we see the Indian manufacturers, what they are facing challenges such as delayed deliveries, inconsistent qualities, and higher production cost. These issues directly reduce their appeal to global buyers and make it harder to compete in the international value chains. So that is why the adoption of Industry 4.0 is not a choice, but it is a strategic necessity. It is the key to ensuring that Indian manufacturing remains competitive, resilient, and globally relevant in the years to come. See, another useful, or we can say powerful reason for adapting Industry 4.0 today is growing demand for customization. Means what? Consumer behavior has shifted very drastically. Means customers, whether they are buying cars or clothing or footwear or electronics, they no longer want just standardized products. They now expecting items as per their individual needs, individual styles and preferences. Means what? They need customization. So this is where Industry 4.0 technologies make impossible to possible. So tools such as additive manufacturing, means 3D printing, or we can say AI-driven design systems and flexible robotic assembly lines, that all enables companies to produce what we call batch size of one. Means in other words, we can say that each product can be unique yet produced efficiently without sacrificing the cost or delivery timelines. So this is all about Industry 4.0. The need of Industry 4.0 means customization demand. Okay, for example, if we consider the Indian footwear industry, then the AI-powered design tools can create customized shoes based on customers' exact foot scan. Means what once required lengthy manual work now can be done at scale quickly and cost effectively. Okay, so this is the power of Industry 4.0. So this kind of flexibility was nearly impossible in earlier industrial eras, where production lines were rigid and designed for mass and identical output. Okay, another is what? Another need is cost reduction and efficiency gains. We can call this as a critical driver for adapting Industry 4.0, that is cost reduction and efficiency gains. In this, we can say that, or we can see that today industries are facing rising cost of labor. So labor, there is very shortage of labor in India. Raw materials are also, energy also, while profit margins continue to shrink. Okay, so this means they profit margins are very reducing because of these all. So this makes it absolutely essential to adapt smarter, more efficient production system. And Industry 4.0 provides exactly that. With automation, real-time monitoring, and data-driven decision-making, factories can operate with far greater efficiency and reliability. For example, if we consider the example, IoT sensors, all of we know IoT, Internet of Things sensors are there. Means if we implement the IoT sensors, means I'm telling one example, key IoT sensors which are there that continuously monitor machines and detect even the slightest deviation in performance, allowing companies to fix their issues before breakdown occurs. So this avoids expensive downtime and ensures very smoother operations. So let me give you one real-time example. An Indian steel plant. In Indian steel plant, they have implemented AI-based rolling mill control, which achieved significant fuel savings and higher yield, directly boosting profitability. Means because of the AI-based rolling mill control, they have saved fuel and increased the yield. Means there is a direct, they have impacted on the profitability. Okay. Another major reason why Industry 4.0 is essential today is the growing importance of sustainability and resource efficiency. So sustainability is not longer just a corporate good to have word, but it is a regulatory and market necessity. With the increasing environmental regulations and highlighted consumer awareness, manufacturer must find ways to reduce the emissions which are harmful to human beings, harmful to environment, minimize the waste, and optimize the use of resources. So Industry 4.0 provides powerful tools to achieve these goals. Precise monitoring and control of resource consumptions can make companies make their operations not only smarter but also greener, which is very essential for maintaining the sustainability and resource efficiency. For example, if we took the example of Indian textile factories, then there they have implemented IoT-based water management system, which shows that the ability to reduce water usage during the dyeing process by up to 30%, means they have reduced the water usage by 30%. Similarly, if we go for predictive analytics, then that predictive analysis help the forecast demand more accurately, preventing overproduction and excess inventory waste. See, this Industry 4.0 is not simply an optional upgrade. It is the survival strategies for Indian manufacturing. It is the pathway that will allow our companies to remain globally competitive, meeting the rising demand for customization and achieve significant efficiency and cost advantage. At the same time, it also helps to align with sustainability goals. So most importantly, Indian Industry 4.0 prepares us for future where digital and physical systems are deeply intertwined. Okay, where humans, machines, and data work seamlessly together to deliver innovation and quality. So the choice before us is very clear. Either we need to adapt to this transformation and lead, or risk being left behind. So choice is ours, and we need to choose the Industry 4.0 transformations. Okay, so when we talk about Industry 4.0, it is very important to recognize that it is not driven by a single technologies. Single technology is not there. There is a mixture of technologies. There is a huge the mixture of technologies are there. Okay, it is the convergence of multiple digital innovations which are working together that transforms the traditional factory into smart factory of the future, isn't it? Smart factory of the future is there because of the Industry 4.0 only. These are the enabling technology which we have seen previously. Enabling technologies. These enabling technologies empower machines, systems, and humans to interact seamlessly. They facilitate intelligent decision making and pave the way for self-optimizing production processes. First is industry. The first enabling technology is Internet of Things. Okay, the first and most we can say fundamental pillar of Industry 4.0 is Internet of Things. So these are enabling technologies. Means these are required in Industry 4.0. These are must to use technologies. First one is the Internet of Things. Simply put, we can call that as a IoT, which refers to network of interconnected devices, machines, and sensors that continuously collect and exchange data. In manufacturing context, this means production machines, assembly lines, and even logistics systems can communicate with each other in real time. Sensors measure key parameters So what are the key parameters? Sensors can measure temperature, vibration, pressure, machine speed, and this data is transmitted instantly for monitoring. Okay, this information is transmitted for monitoring as well as decision-making purpose. One of the greatest benefit of IoT in manufacturing is predictive maintenance. Instead of waiting for machines to fail, in that case, sensors can detect anomalies, means what are the problems in the machines early and alert engineers before breakdown occurs. So this prevents costly downtime and ensures smoother operations. Take an example, Indian automotive plant. So in Indian automotive plant, IoT sensors embedded in conveyor belts can track vibration and bearing wear. So by predicting issues in advance, the plant can schedule timely maintenance, avoid production halts, and can save lakhs of rupees in productivity losses. So this is the benefit of Industry 4.0. Okay, the next most powerful pillar is artificial intelligence and machine learning. So we can call that as a brains of Industry 4.0 or brains of smart manufacturing. Okay, AI ML allows us to process massive volume of data. Yes, is there any issue?
No, ma'am, you can continue.
Okay, okay. I will share my screen.
Yes, sir.
Are you getting my point, all of you?
Yes, ma'am.
Okay. So see, second important pillar is artificial intelligence and machine learning. We can call that as a brain of smart manufacturing. So what exactly AI and ML do in Industry 4.0? So this artificial intelligence, machine learning, they process massive volumes of data, very huge volumes of data, and they generate intelligent insights that human analysis alone could never achieve at the same speed or accuracy. Human errors are always there, but if we implement artificial intelligence and machine learning, they can generate intelligent insights. Okay, for example, if we take the quality inspection as an example, then AI powered vision systems are there that can detect even the smallest defects in parts, sometimes which are invisible to human eye, but because of AI powered vision systems, that ensures higher standards of quality with very small amount of errors. Another critical application, if we take, that is demand forecasting. So demand forecasting means what? See, AI models are there. We know Amazon, we know Flipkart, we know all the websites, online marketing websites which are there. We all know that. There they use the artificial intelligence, machine learning. For what purpose? For demand forecasting. They use AI models to analyze what? They use AI models to analyze a wide variety of inputs. They analyze past sale patterns. They analyze seasonal trends. They analyze even consumer sentiments which are expressed on social media. And this enables all the online shopping companies which are there, like Amazon, Flipkart, Myntra, all are there. Okay, so these enables companies to predict demand with precision, and because of that they can prevent both overproduction or underproduction. Okay, if we take another example as textile mills, then AI can be used. AI has used there also. AI systems can now sort fabrics by quality and color variations with up to 99% of accuracy. So this result reduced the wastage, improved consistency, and far greater consumer satisfaction. In short, we can say that artificial intelligence and machine learning transform the data into actionable intelligence, empowering manufacturers to make smarter, faster, and more reliable decisions. Another cornerstone of Industry 4.0 is what is big data and analytics. So the IoT sensors means, in that if we see the IoT sensors which are there, which generate large data on the shop floor, ERP system tracking operations, and even customer interactions, they require robust platforms that can collect, process, and interpret it in real time. So this big data analytics make it possible to move beyond intuition and guesswork, enabling data-driven decision making. For example, machine settings can be automatically adjusted the moment a quality deviation is detected. Means if there is a deviation, if there is a problem in quality, then it can be detected directly by data-driven decision-making systems, which can be used to reduce the defects and which save the valuable resources also. In the area of supply chain management, the market is very huge for supply chain management. Okay, in this area, the analytics can optimize everything from raw material sourcing to transport routes and inventory control. This ensures not just cost saving, but also timely availability of goods. If we consider the FMCG companies, so FMCG companies, if we consider, so by applying advanced analytics, means big data analytics, if that technology we apply in FMCG companies, then it is means for them it is very useful or helpful for the distribution network. It can ensure that products are always available at neighborhood kirana stores, we call that, okay, at the right time and in the right quantities. In short, we can say that big data and analytics give manufacturer the power of foresight, the ability to anticipate problems, optimize processes, and respond to market demands with very effectively. Okay, another key pillar is what? It is a cyber physical system. So cyber physical system means what? Often we call that as a backbone of smart manufacturing. So CPS, short form is CPS, cyber physical system. So CPS integrates, what it integrates? It integrates digital intelligence with physical assets. This means that every machine, every production line, and every process is equipped with a digital layer of sensors, softwares, and control system that continuously interact with the real world. The result is an environment where machines are not just automated, but also interconnected and responsive. They can talk to each other, collaborate, and even adjust their operations in real time, often without human intervention. For example, imagine a CNC machine. What exactly CNC machine does? CNC machine, if is on the shop floor, which detects a minor misalignment, instead of waiting for operator to notice it and fix it, the machine can instantly signal a robotic arm to readjust the positioning, ensuring precision and avoiding defects. That is there, the use of CPS, that is cyber physical systems. So this kind of tight integration makes the entire system more adaptive, resilient, and efficient. It reduces errors, minimizes downtime, and ensures that production continues smoothly. Okay, so cyber physical systems brings us closer to the vision of truly self-optimizing, intelligent factory, isn't it? Another pillar is what? Another pillar is digital twins. What is meant by digital twin? Digital twin is essentially a virtual replica of physical asset, machine, or even an entire factory. It allows engineers and managers to monitor, simulate, and optimize operation in the digital world. Important is before making changes in the physical world. That is the importance of digital twins. And this technology dramatically reduces risks. It improves the efficiency. It saves the cost. If we take example of digital twin, of automotive assembly line. So before introducing a new car model, a digital twin can simulate the entire production system, identify bottlenecks which are there before, and fine-tune operations, all without disrupting the actual factory floor. That is the importance of digital twin. See, please mute them.
हा बोला की हो आम्ही भाडे घेत आलोय
Lot of noise is there. Shreya madam, please handle that all. Uday sir.
येस मॅम
So in India, digital twins are already gaining momentum, particularly in aerospace and automotive industries. See the use of digital twin technology. It is already gaining momentum in India, but in aerospace and automotive industry, where we require higher precision and cost efficiency, and risk minimizations are very critical in that cases. So by bridging the gap between virtual design and real world production, digital twins enable manufacturers to move faster and operate smarter. Okay, so this is all about digital twin technologies. Another powerful pillar of Industry 4.0 is 3D printing, that is also known as additive manufacturing. So this means, unlike traditional manufacturing, which cuts or removes the material, what 3D printer actually does, 3D printing builds objects layer by layer directly from digital models. And this approach is transforming the way the industries design and produce parts. One of the biggest advantage is rapid prototyping. Engineers can now design, test, and redefine the product models in just a few days instead of waiting weeks for conventional machining. So this dramatically speeds up the innovation cycles. It also brings material efficiency and performance benefits, isn't it? In aerospace and automotive applications, for example, 3D printing is used to produce lightweight but equally strong components. So these lighter parts reduce fuel consumption. What is the use of that? It is used to reduce the fuel consumption, lower cost, and improve energy efficiency. We can see a striking example comes from aviation. So what happened there? When 3D printed engine components have cut down weight while maintaining the strength, resulting in significant fuel saving and long-term operational efficiency. In short, we can say that 3D printing empowers industries to be faster, smarter, and more sustainable, isn't it? Another exciting set of technologies powering Industry 4.0 are augmented reality and virtual reality. See, the world is growing very fastly, changing very fastly. We need to study these augmented reality and virtual reality technologies. These immersive tools are transforming how workers interact with machines, processes, and training environments. Augmented reality means what? It overlays the digital transformation onto the physical world. Imagine a factory worker wearing AR glasses and seeing step-by-step assembly instructions projected directly onto the machine, isn't it? This drastically reduces errors, shortens the training time, and boosts the efficiency, isn't it? VR means what? Virtual reality takes it a step further by creating fully immersive simulated environment. Workers can train on complex procedures like welding or equipment repair without risk and without wasting materials. For example, if we can take the example of AR can guide an electrician to correctly wire complex panel by showing the instructions directly onto the object. Meanwhile, if we consider VR, virtual reality, simulators are there. So simulators can prepare welders or machines operators in a safe, realistic, and cost-effective environment. So together, this AR/VR technology can improve the accuracy, safety, and skill development, making them very important technology for building the workforce of future. Okay, see, another enabling technology is what? Cloud and edge computing. So this is transformative technology. Cloud computing, what it does, it provides virtually unlimited storage and powerful centralized platforms to process the enormous amount of data generated by smart factories. It enables advanced analytics and collaboration across locations, isn't it? But many industrial processes demand real-time decision making. Means a machine cannot wait for data to travel back and forth to a remote server. That's where edge computing comes in. So by processing the data right at the machine or factory floor, edge computing reduces latency and ensures instant responses. For example, if we consider the Indian pharmaceutical factory, edge computing can instantly detect a packaging error in a batch of medicines, means which pill is missing or not. That we can detect with the help of cloud computing and edge computing. While the cloud computing maintains the long-term production records for regulatory audits. We need cloud computing. Okay, so together the cloud and edge computing create a balance of speed, intelligence, and scalability. And because of that, factories can operate seamlessly in real time while staying prepared for future demands. The final pillar is blockchain technology. So blockchain, which brings security, trust, and transparency to manufacturing ecosystems. In today's complex supply chains, where raw materials pass through multiple hands before reaching the final consumer, maintaining the authenticity is very, very critical. And because of blockchain, we can do that. Blockchain creates a tamper-proof distributed ledger where every transaction from sourcing raw materials to final product delivery is permanently recorded. See, this blockchain technology ensures traceability of goods, prevents counterfeiting, and strengthens the customer confidence. For example, if we consider the Indian food industry, so what is there in Indian food industry? So blockchain can trace the exact origin of fruits, vegetables, right from farm to supermarket shelf. So such transparency not only assures the consumers of quality, but also helps reduce fraud and food safety risk. So by integrating this blockchain technology, by using this blockchain technology, or by using all these enabling technologies, our industries can gain a secure, transparent, and trustworthy system that is increasingly demanded by both regulators and global buyers. Okay, when we look at the global leaders in smart manufacturing, few key examples are there, each offering valuable lessons for India. For example, if we consider Germany, okay, the birthplace of industry, Germany is nothing but it is a birthplace of Industry 4.0, is a pioneer. Its success lies in strong collaboration between government, industry, and research institutions. See, this Germany actively supports small scale and medium scale enterprises through funding programs, skill development, experimental test beds. And this ensures that not only large corporations, but also small manufacturers benefit from digital transformation. If we took the example of China, China has adopted an aggressive approach through Made in China 2025 initiative. With massive R&D investment, AI adoption, and subsidies, it is building world-class, China is building world-class digital infrastructure while reducing the dependence on foreign technologies. So the strategy focuses on scaling Industry 4.0 across critical industries like electronics, automotive, and aerospace. If we consider United States, then United States follows a different path. that is driven by open standard, interoperability, and strong public-private collaboration. Through initiatives, there in US, initiatives are there like Smart Manufacturing Leadership Coalition. The US promotes test beds, cybersecurity frameworks, and workforce upskilling. Unlike China, it emphasizes scalable, low-risk innovation instead of direct subsidies. Then what the lesson is there for India from all these countries, Germany, China, US, what India should take, what are the takeaways for India, what are the lessons for India? From Germany, we must learn the value of ecosystem collaboration and SME inclusion. From China, the India should learn the importance of large-scale investment and digital infrastructure. From US, the India should learn to focus on open systems, cybersecurity, and workforce readiness. If India combines these lessons with its own strength, like a vibrant IT sector, skilled engineers, and growing startup ecosystem, we can accelerate the transition to globally competitive, sustainable, smart manufacturing. So these are the lessons for India. One of the most important lesson for India is the need for collaborative innovation hubs. Okay, so India must establish regional industry 4.0 innovation hubs, ecosystems where government, academia, and industry come together to co-create solutions. These hubs can serve multiple purposes. They can act as demonstration centers showcasing real-world applications of smart manufacturing. They can function as training grounds, isn't it? Where engineers, managers, and students gain hands-on exposure to advanced technologies. And most importantly, they can operate as pilot test beds for small and medium enterprises, giving small and medium enterprises the confidence to experiment with automation, AI, IoT, and digital twins without heavy financial risk. So this model is inspired by Germany's Competence Center, which have successfully accelerated Industry 4.0 adoption across sectors. Another small lesson for India is the need to design affordable and scalable solution for SMEs. Okay, we must remember that over 90% of Indian manufacturing units are SMEs. For them, large-scale, capital-intensive automation, what we have seen in Germany, China, or US, will not be practical or feasible. Instead, the focus should be on modular, low-cost technologies that can easily integrate with their existing infrastructure. Means, for example, if we retrofit IoT sensors onto old machines to enable real-time monitoring, using cloud-based ERP system that reduce upfront IT investment, adopting low-cost collaborative robots, means cobots, that can safely work alongside the human workers. At the same time, the local startups and indigenous innovation must be encouraged. India has a unique opportunity to lead in frugal Industry 4.0 solutions, which are tailored to its own needs, such as energy efficient systems. Energy efficient system, what it does? Energy efficient systems reduce the production cost, isn't it? Pay-per-use digital platforms are there, which allows SMEs to access advanced technologies without heavy financial burden. So by taking this approach, India can ensure that benefits of Industry 4.0 are inclusive, reaching not just large corporations, but also the small and medium enterprises that form the backbone of our economy. What is another key takeaway for India is workforce reskilling. So one of the biggest challenge we face is that large portion of our workforce is employed in traditional manufacturing. If we move toward Industry 4.0 without preparing them, we risk widespread job displacement. Therefore, reskilling is not optional. It is absolutely essential. India needs to launch nationwide reskilling and upskilling programs in areas such as artificial intelligence, data science, robotics, data analytics, and digital manufacturing. Isn't it? These programs can be delivered effectively through ITRs, engineering colleges, and skill development centers across the country. Moreover, new age tools like AR/VR based digital training modules can make learning both accessible and scalable. These modules allow workers to gain hands-on training in simulated environments, preparing them for human-machine collaborations in smart factories. Isn't it? By reskilling our workforce, we will ensure that India's transition to Industry 4.0 is not just about technology adoption, but also about empowering people to thrive in the digital manufacturing era. Isn't it? Next key takeaway for India is current status of Industry 4.0 adoption in India. We should know that what is the current status of Industry 4.0 in India. Now we'll take a look. Okay. See, Indian manufacturing sector is indeed undergoing a transformation. But we must recognize that we are still at a relatively early stage of embracing Industry 4.0. At the heart of this ecosystem, our micro, small, medium enterprises. They are the backbone of Indian industry, contributing nearly 30% of country's GDP and accounting for 45% of total manufacturing output. Yes, despite this significant role, the majorities of MSMEs continue to operate with outdated machineries and manual processes, showing what they are showing. They are showing low levels of automation and digital adoption. So they are not adapting this Industry 4.0 technologies. They are not adapting this Industry 4.0 enabling technologies. On the other hand, large firms, particularly in automotive, electronics, and pharmaceutical sectors, they have begun adopting advanced technologies such as IoT, predictive analytics, AI-driven quality inspection system. But these should be used in MSMEs also. Then and then only India can, miss the 30% of India's GDPs, which are counted by MSMEs, that can be increased. However, this program is uneven across states. It is uneven. Okay. Industrial clusters like Maharashtra, Gujarat, Tamil Nadu are much ahead in digital readiness, while many regions in the east or north of India still rely heavily on traditional methods. This reality highlights a dual speed adoption of Industry 4.0. See, this data I have taken from Google. Okay. So Maharashtra, Gujarat, and Tamil Nadu are much ahead in digital readiness. Also Karnataka, but some part of Karnataka. Okay. So this reality highlights a dual speed adoption of Industry 4.0, where some sectors and some regions are rapidly advancing, while others lag behind. If India is to truly harness the power of Industry 4.0, we must bridge the gap and ensure that both large firms and MSMEs move forward together in digital transformation journey. While the opportunities are immense, isn't it? We must also acknowledge the challenges that Indian manufacturing faces while moving towards the Industry 4.0 adoption. So first major challenge is what? The first major challenge is higher initial cost. Okay. So advanced technologies such as industrial IoT platforms, robotics, digital twins require heavy investment. For most of the MSMEs, this is simply not affordable. Large corporations, unlike that large corporations, small firms find it very difficult to justify the short-term return on investment, which can slow down that adoption. Okay. The second challenge is the lack of skilled workforce. India indeed has an advantage of young demographic, but there is a clear mismatch between skills and industry needs. We all know we are creating engineers, but these are not skilled engineers, isn't it? That's why Government of India is giving different platforms. Okay. Large portion of our workforce has not been trained in AI, robotics, cloud platforms, or cyber physical systems. This gap creates hesitation in adopting automation, isn't it? If India is to fully embrace Industry 4.0, it is essential to lower cost barriers and build a skilled, future-ready workforce, isn't it? Another key challenge is fragmented supply chain. So fragmented supply chain means what? In India, supply chains are often disorganized and poorly integrated, with limited visibility across vendors, logistic providers, and distributors. And this lack of coordination results in inefficiencies, frequent delays, and even quality issues are there, which make it extremely difficult to implement end-to-end smart manufacturing. Unless the supply chains are digitized and streamlined, the promise of Industry 4.0 remains only partially fulfilled. The next major challenge relates to cybersecurity concern, which is essential in Indian industries. Okay, so this, as factories and enterprises become increasingly connected, they also become more vulnerable to cyber attacks, data theft, and system disruption. Unfortunately, many MSMEs in India either lack awareness about these risks or do not have the financial capacity to adopt robust cybersecurity measures. In previous lecture, we learned about cybersecurity, isn't it? So cybersecurity measures, what MSMEs which are there, they must adopt robust cybersecurity measures. So this robust cybersecurity measures makes smaller firms hesitant to fully digitize, as the fear of being exposed to cyber risk often outweighs the perceived benefit of automation. Cybersecurity is must in every Indian industry, isn't it? Next one. While the challenges are significant, India also has tremendous opportunities are also there. We should know that tremendous opportunities to leapfrog into smart manufacturing, isn't it? One of the strongest enabler is government's flagship programs such as Make in India and production-linked incentive schemes, that is PLI schemes, isn't it? So these initiatives, these are opportunities. These initiatives have already started attracting large-scale investment in critical sectors like electronics, semiconductors, automotive manufacturing, isn't it? By trying incentives to higher productivity and quality outcomes, these schemes are encouraging firms to embrace advanced technologies, from automation to robotics to digital quality control, isn't it? So that Indian products can consistently meet the global benchmarks. In other words, we can say that government-led policies which are there, they are creating a strong push for technology-driven competitiveness, laying the foundation for widespread use of Industry 4.0 adoption, isn't it? Another major opportunity comes from nationwide rollout of 5G network. We all know 5G network, isn't it? So with 5G, factories will finally have access to ultra reliable, low latency communication between machines, sensors, and control system. So this 5G rollout networks. They open the door for real-time monitoring, predictive maintenance, and even fully autonomous operation. In simple terms, we can say that 5G is the backbone that will make truly connected, intelligent factories a reality in India. At the same time, there is increasing global demand for high-quality exports, isn't it? As international supply chain gradually diversify away from China, okay, India is uniquely positioned to emerge as a major manufacturing hub. But to meet the strict international standards of quality and traceability, our industries must adopt Industry 4.0 technologies. That is from blockchain for supply chain transparency and AI for defect detection and IoT for end-to-end product tracking. So this shift will not only boost India's competitiveness but also strengthens its reputation as a trusted global supplier. See, the government of India has already taken some strong steps to accelerate the Industry 4.0. What are that strong steps? First key initiative is Samarth Udyog Bharat 4.0. So this program promotes smart and advanced manufacturing technologies by establishing what? By establishing demonstration centers and test beds across the country. These centers give our SMEs a safe space to experiment with automation and digital solution before committing to full-scale investment. And because of that, it makes advanced technologies more accessible and less risky. Another important step is what? Another important step is National Manufacturing Policy, that is NMP. The vision here is to increase the share of manufacturing in India GDPs to 25%, isn't it? To achieve this, the policy emphasizes on what? The policies emphasizes on innovation, research and development, skill development, and cluster-based growth. In short, it provides a strong foundation to make Indian manufacturing more globally and competitive. Okay, the government is also supporting Industry 4.0 adoption through targeted incentives and skill development programs. So the production link incentive or PLI schemes, if we see in sectors like electronics, automotive, and semiconductors are great examples. Production link incentive, that scheme. Okay. These schemes provide financial incentive to companies that achieve higher production rate, while at the same time encourage the integration of automation, digital monitoring, and sustainable practices. In other words, we can say that they reward firms that embrace smart technologies and make India globally competitive. So these are the government initiatives. Another government initiative is what? On the other hand, to prepare our people for this digital shift, the government has launched large-scale reskilling mission, the Skill India mission, and the Pradhan Mantri Kaushal Vikas Yojana, or this is by Government of India, or Acharya Chanak Kaushal Vikas Kendra by Maharashtra government. Okay, these are the Skill India missions. They are actively training workers in IoT, robotics, AI, artificial intelligence, CNC programming, and digital manufacturing. These initiatives aim to create a future-ready workforce. Future-ready workforce that is not left behind, but instead becomes the backbone of India's smart factories. Now I will share some case studies and success stories in Indian manufacturing. Okay, one of India's most compelling success stories in India Industry 4.0 comes from Tata Steel's Jamshedpur plant. So what exactly is there? As we know, blast furnaces are the heart of steel production, isn't it? But they are extremely complex and prone to unplanned downtime, which directly impacts output. See, these success stories or case studies I have studied from different research papers, Google. Okay. From that, I have taken these success stories. To address this, the Tata Steel embedded IoT sensors across critical furnace zones, which continuously track the temperature, pressure, and gas flow. The data was analyzed in real time, which allow the engineers to detect even the slightest deviation and take corrective action before failure occurred. And the results were very remarkable. Downtime was reduced by 15%, leading to higher productivity and significantly lower the operational cost. The lesson here is very powerful. What is the lesson? Even in heavy industries with massive infrastructure, the targeted IoT deployment in the right areas can deliver measurable efficiency gains. The strategy is to start small, focus on high impact areas where even modest improvements can translate into massive savings, isn't it? Another inspiring example comes from Bosch India's Bangalore plant. Bosch India, Bangalore plant is there. Means in Bangalore there is plant which has been transformed into a small factory. At the heart of this transformation lies the use of digital twin. So what they have used, digital twin technology they have adopted. Digital twin means what? A virtual replica of the physical assembly line. With this tool, engineers can simulate changes, optimize workflows, and test machine settings in virtual environment first before making adjustment on the actual shop floor, isn't it? So the impact was significant in the Bosch India. This approach reduced costly errors and disruptions while enabling more data-driven decision making, and the result was 10% improvement in productivity, which proved that the real value of digital first thinking means digital twin technology. So the key lesson here is very clear. What is the key lesson? If we implement digital twin, if we implement Industry 4.0 digital twin technology, then that can minimize the risk and accelerate optimization. For factories in India that are considering Industry 4.0, starting with virtual first experimentation approach is both cost effective and very flexible, isn't it? So paving the way for smarter, more efficient operations. A very powerful example of AI in manufacturing comes from Bharat Forge in Pune. Traditionally, quality inspection relied heavily on manual checks, which were not only slow down, but also prone to missing subtle defects. So in Bharat Forge, they have introduced AI-based computer vision system. High resolution cameras coupled with AI models they have implemented, and they inspect every forged part with speed, consistency, and precision. The results were very striking. The company achieved 20% reduction in defect rate, ensuring consistent product quality, while also strengthening its global competitiveness and customer trust. The lesson here is very clear. AI-powered automation delivers accuracy at scale. Means in many cases, in traditional factories, quality inspection is weak link, isn't it? But with AI, manufacturers can guarantee zero compromise on quality while allowing human workers to focus on higher value tasks, isn't it? Not all success stories come from big corporations. A small auto part manufacturer in Rajkot, Gujarat is SME, small scale industry is there in Gujarat, was struggling with frequent machine stoppages that hurt its productivity. Instead of going for large, expensive automation system, the company chose a frugal Industry 4.0 solution. It installed a low-cost IoT sensor on its production machines. The sensors, what they done? The sensors tracked utilization rates, downtime, and overall machine performance. By analyzing the real-time data, the company identified hidden inefficiencies such as excessive idle time and unplanned stoppages. So with targeted interventions, it managed to improve overall equipment effectiveness, that is OEE, from 65% to 82% in just 6 months. So the key lesson here is what? SMEs don't need massive investment to benefit from Industry 4.0. Even affordable modular IoT solution can drive quick and visible results, particularly in improving machine utilization and reducing the downtime. So this is the summary. This table shows 4 examples, 4 case studies, which we have now discussed. What technology they have used, the impact of that technology on that particular industry, and what lesson the others should learn from these cases, case studies, success stories is shown here in this table. Okay, so this is all about Industry 4.0. My topic is what the roadmap for implementing Industry 4.0 in Indian manufacturing. And for this preparation of this, I have referred these references. I have taken the study reports from Niti Aayog, CIN, PwC, okay, McKinsey, Samarth Udyog Bharat 4.0 initiative. Just I want to tell you that PwC means what? See, this here PwC word is there, isn't it? What is PwC? So PwC stands for PricewaterhouseCoopers. It is one of the world's big 4 professional services firms, alongside Deloitte, EY, KPMG. This PwC, what it does? This PwC provides audit and assurance services, consulting, tax and legal advisory, deals and strategies. Okay. See, this PwC operates in over 150 countries. And in India, it is known as PwC India, which offers the advisory and consultancy services to industries, which are in the manufacturing, IT, finance, and public sector. So this is all about my today's topic. So if you are having any doubts, the floor is open to all the participants.
Participants, please ask the question if any. Hello, good evening. Is there any question about today's topic? Okay, then Rajni ma'am, you can take over.
Yes, sir. Thank you so much. Good evening, everyone. On behalf of Ashok Ramane Group of Institutions, Kolhapur, I extend a warm welcome to all the dignitaries, respected speakers, faculty members, and participants present here for the valedictory function of the AICTE ATAL Online Faculty Development Program on Next Gen Manufacturing, Embracing Industry 4.0. Over the past 6 days, this FDP has been a journey filled with knowledge, insights, and meaningful discussions. And today, we gather to formally conclude it with gratitude and reflection. To begin the valedictory function, it is my privilege to invite our respected director, Dr. Mrs. S.R. Choubule ma'am, to kindly address the gathering with her thoughts and words of guidance.
Okay. Good evening, everyone.
Good evening, ma'am.
Madam, is it audible?
Yes,
Yes,
ma'am.
yes.
Yes, it is audible.
Yes, audible, madam? Hello.
Hello, ma'am. You are audible, ma'am.
Yes, ma'am.
Yeah,
You are
yes.
audible, ma'am. Perfectly
Yeah,
audible.
okay. So, yes, good evening, everyone. It gives me immense pleasure to be
ma'am.
with, yeah, It gives me a pleasure to be with you today at the valedictory function of the AICT ATAL Faculty Development Program on a next generation manufacturing in Massive Industry 4.0. Over the past 6 days, we have witnessed enriching sessions delivered by the distinguished academicians, researchers, and industry experts covering the latest trends in Industry 4.0, IoT, AIML, automation, and sustainable smart practices. I am confident that each one of you is taking back valuable insight that will strengthen your teaching, research, and professional contribution. On behalf of Ashok Ramane Group of Institute, I extend my heartfelt thanks to all the participants, speakers, coordinators, and AICT Atal Academy for their support in making this FDP success. Friends, before we conclude, I am delighted to share an exciting announcement. Our institute is organizing the International Conference on Integrated Research and Sustainable Development. So, jointly with the 45th GISP Standardization Series meeting from 30th of October to 1st November 2025. So, at AMGOI, Vathar, Kolhapur. The theme of the conference involves around digitization, bridging the present and future, and it will feature global experts, eminent academicians, policymakers, and industry leaders. Selected quality papers will also find the publication opportunity in a Springer series as well as in a Scopus journal. So I request all the participants convey the message to your colleagues, your PhD scholar students, also PG students, which will they take the benefit of this very nice opportunity which we are going to organize in our institute. So I take this opportunity to warmly invite and appeal to all of you to actively participate, contribute papers, and join us in the global knowledge sharing platform. Your presence will surely add immense value to the success of the international event which we are going to organize. Once again, congratulations to all participants for successful completion of this FDP. I wish you the very best in your academic and professional journey. Again, our team, AMGOI team, actively participate.
Okay, thank you very much.
All the team members are contributed for the conduct of this workshop, FDP faculty program, and the distinguished personalities again. Enthusiastic speakers are there. So thank you very all of you being a part of this FDP. Thanks. And good evening again. Thanks.
Thank you very much, ma'am.
Thank you very much, ma'am, for your inspiring and motivating words. Your vision continues to guide us towards the excellence. And thank you for the invitation of the conference to all the participants. I hope all the participants are eager to take the part in this conference. And the details of the conference will be shared on the WhatsApp group also. Please kindly go through it. And we are eager to welcome you all at our institute. Now, I take this honor of inviting our respected FDP coordinator, Dr. C.R. Dongarsane sir, to share his reflections on the successful conduct of this program. Over to you, sir.
Thank you, Shwetali ma'am. So, good evening, everyone. It is indeed an honor to stand before you at the valedictory function of this AICT ATAL Faculty Development Program on Next Gen Manufacturing Embracing Industry 4.0. Over the last 6 days, we successfully conducted 13 knowledge-rich sessions delivered by distinguished experts from academia and industry as well. The insights they shared on IoT, IIoT, artificial intelligence, machine learning, smart sensing technologies, industrial automation, cybersecurity, smart energy systems, and sustainable manufacturing practices have truly enriched our understanding of Industry 4.0. At this moment, I would like to place on record my heartfelt gratitude to all our eminent resource persons. First, we start with Dr. Suresh Mikili from NIT Goa for enlightening us on the innovation development, TRL, and the role of IoT in automation. Then Mr. Arijit from Citron C Zentrix for his inspiring session on design thinking and product development 4.0. Then Mr. Rajshekhar Uchil, International Society of Automation, for his session on smart sensing technologies and tech trends. Then Mr. Bhaskaran S. From InvoSystem Solutions Singapore for his deep insights on smart tools for monitoring carbon footprint. And then Dr. Jayesh Barve from GE Research for his valuable talk on industrial automation and IIoT. Then Mr. Mohan Patel, industry expert and consultant, for highlighting recent trends in automation. Then Mr. Rohit Kadam from Robosap Innovation for sharing a real-world application of AI and AI/ML manufacturing. Then Dr. Deepak Vaikar from IEEE Singapore for his talk on smart energy systems and smart transportation. Then Mr. Sanjeev Sharma, today's guest expert from ABB India for sensitizing us about cyber security for critical infrastructure. And finally, Dr. Seema Patil, ma'am, our Dean Academics from AMGOI, for his session on the roadmap for implementing Industry 4.0 in Indian manufacturing. So thank you very much, all the guests. And Seema Patil, ma'am, your today's session was very good.
Thank you,
very
sir.
informative, very nice session. So each of them has made this FDP a valuable and memorable learning journey for all the participants. I also take this opportunity to express my sincere gratitude to our management, campus director, dean and HODs for their continuous encouragement. A very special thanks to my colleague and coordinator, Dr. Seema Patil, for his tireless efforts and leadership in organizing this FDP.
Thank you.
And above all, I would wholeheartedly thank all participants for your active encouragement, discussion, and positive feedback. Without your enthusiastic participation, this FDP would not be having so impactful. As we conclude, let us carry forward the learning of this FDP and contribute meaningfully to research, academics, and industry, keeping in mind the vision of Industry 4.0 and beyond. So thank you one and all. Over to you, Shwetali ma'am.
Yes, thank you, sir, for your words of encouragement and highlighting the efforts that made this FDP possible. I can also see the comments from the participants. Thank you so much. We are really very happy to receive all these positive comments from the participants. Your appreciation and feedback truly encourages us. And FDP is almost incomplete only when we hear the voices of our participants. So I request all the participants that if possible, please kindly share your experiences, suggestions, and feedback, which are valuable to us. I request if anyone is interested. Yes, sir.
Shwetali ma'am, just want to mention Dr. Deepak Vaikar sir joined us for this valedictory function. So all
Yes,
of
sir,
you, please
welcome, sir.
Welcome,
I welcome you on
Thank
behalf
you for
of
joining.
Ashokram and a group of institutions. It's very nice of you that you took time for us for this valedictory function, sir.
Yes.
Thank you for invitation. So Seema ma'am said and Dr. Chetan sir, so then okay, I joined.
Yes, yes.
Sir, we need your cooperation in future also.
Yes, sir.
बस आप हमें निमंत्रण भेजिए, हम आ जाएंगे.
Yes, sir.
Yes, sir. That's so nice of you, sir. Thank you so much.
Thank you for your gesture, sir.
Thank you. Thank you, sir.
So we have received a comment from Krishna Kumar, sir. Just a moment.
Yes. Yes.
We have received many comments, so I request you, if please you can unmute yourself and please say a few words over here. We will be delighted, sir.
Yeah, Shwetali ma'am.
Yes.
Yes.
Oh, Krishna Kumar Joshi, sir, see, he's saying that the speakers are not working. Okay, no issues, sir.
Okay. We'll do closing remarks, ma'am.
Yes, ma'am. Okay, we will move forward.
Yes, yes.
To bring this valedictory function to a graceful close, I now invite our respected co-coordinator, Dr. Sima Patil ma'am, to kindly deliver the closing remarks.
So, good evening, all of you. As we
Good
come
evening, ma'am.
to this enriching 6 days ATAL FDP on next gen manufacturing embracing industry 4.0, it gives me immense satisfaction to reflect on the knowledge, discussions, and insights we have all gained. Over the past week, we have had the privilege of listening to eminent experts from academia, industry, and research who enlighten us on critical aspects such as design thinking, smart sensing technologies, IIoT, industrial automation, AI driven solutions, cybersecurity, and the roadmap for Industry 4.0 in India. So each session added unique values, bridging theory with real world applications also. I sincerely thank all our distinguished speakers for sharing their expertise and experiences with such depth and clarity. I also extend heartfelt gratitude to AICT Atal Academy for providing this wonderful platform and support. I'm also thankful to our honorable management, campus director, Professor P.B. Ghevari sir, our director, Dr. S.R. Chogule ma'am, for their continuous encouragement and guidance and support for conduction and execution of this online ATAL workshop. I'm also very much thankful to all the deans, HODs. I'm also thankful to the anchor, Miss Shwetali Ranjne ma'am and Miss Shweta Kubde ma'am for their continuous efforts for anchoring this. A special appreciation goes to all the participants who have joined us with great enthusiasm, actively engaged in discussions, and made this FDP more interactive and meaningful. I'm also thankful to the special guest, Dr. Vaikar sir. I'm very much thankful to you for joining this valedictory function. Your commitment to learning and adopting new technologies for the benefits of your institution and students is truly commendable. All the participants, thank you very much once again. And I'm confident that the learning from this program will not only enhance our or improve our academic and research pursuits, but also help us prepare the next generation of engineers to be Industry 4.0 ready. So on behalf of Ashok Ramani Group of Institution, I thank everyone involved in making this FDP a grand success. So let us carry forward this spirit of collaboration, innovation, and continuous learning. So wishing you all the best in your future endeavors. And again, I would like to say that the conference which we are having at our AIMJOY, I am the convener of the conference, and I heartily welcome all of you to present your papers, to get the knowledge from that, because we are having, along with that workshop, along with that international conference, the name of that conference is International Conference on Integrated Research and Sustainable Development. So as a convener of that conference, I heartily welcome all of you to submit your paper. Also, along with that conference, we are having international workshop as of 3 days. So you can join in that workshop also, and you can gain knowledge also. So thank you once again. Thank you. Thank you very much.
Thank you, ma'am. I would like to highlight here one thing that respected Deepak Vaikar sir has given us a comment that Badal Atal hai. Sir,
Yes.
are you there, sir?
Yes, sir. Yes. Thank you very much, sir,
Thank you,
for
sir.
your kind support, coordination, and easy acceptance for easy means whatever we have. I think we have invited to you in last FDP also. Which
Yes,
was
yes.
on smart manufacturing, smart cities. Yes.
Smart cities.
Yes, smart cities.
I think so. I was the anchor for sir's session.
Yes,
I
yes.
remember that.
So
And
thank you
I
very much
brought- yeah.
for our invitation for this ATAL also.
Thank you very much for your kind invitation. Last time
Yes.
also I brought industry speakers from Singapore. This time
Yes.
also I got industry speaker from Singapore. And when are your dates for that conference you mentioned, Sima ma'am?
Yes. From 13th. Yes,
Yes.
yes, ma'am, you tell.
Yes, you carry on, Dr. Chetan sir.
from 31st October and 1st November. These are the
Okay.
conferences. So if
Okay.
you have the time, sir, we would like to invite you for the conference also.
Yes.
So, most likely it could be online only because I'll
Okay.
be traveling to Ireland around that time.
Yes.
It's clashing with my other personal
Yes, yes.
engagement. Otherwise, but you just let me know, and we'll if you try to adjust timing,
Yes, sir.
then I can give. I think I
Will be,
spoke on sustainability. You know.
yes, 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 sir.
We will
Will,
share you all the details, sir.
yes, sir. We'll be very honored to have your presence, sir, in that conference and in that international workshop also.
Okay, let us know, and if those dates are what do you call matching, and it's at present 31st is not possible. Maybe other dates maybe we can think about, because I will be in Dublin around that time.
Yes, sir. Okay, okay, sir.
So, but I will
Thank
see
you
that
so much.
if I will see that there are some other speakers from Singapore who would like to speak online. Okay,
Okay, sir. No problem.
so
Yes.
do send me it. Thanks.
Yes, yes, yes. Dr. Chetan will do all the formalities.
Yeah. Yes.
Dr. Chetan is at our technical program committee. He is a member over there.
Congratulations to all of you and all the best.
Yes, yes.
Thank you, sir.
Thank
We
you,
also
thank you, sir.
Krishna Kumar Joshi sir comments. He has also given so very positive feedbacks. Thank you so much, sir. With that, we officially conclude the valedictory function of our AICT ATAL Online FDP. On behalf of the organizing team, I sincerely thank our director, ma'am, our respected campus director, sir, our respected coordinators, our distinguished speakers, and all the participants who contributed to making this FDP a grand success. All the participants also, I thank you so much. Wishing you all continued success in your academic and professional journeys. Have a wonderful evening ahead. Thank you so much. Let's meet again in such a very positive FDP. So I hope you all will also join with the same enthusiasm. Thank you so much.
Thank you all the participants.
Thank you, sir. Thank you so much.
Thanks.
Thank you.
Thank you, Krishna Kumar Joshi, sir. Thank you very much for nice chat. Thank you.
Yes. Participants, I will share you today's feedback link very soon. Okay. Thank you all. Good night.
Okay. One more thing. We'll share questionnaires. Means there is a test on this particular feedback. So we'll share on our group. The test will be shared on our group. Okay. So you have to solve that test within 1 day. Thank you.
Thank you, ma'am.
Yes.
Thank you, sir. Thank you, Vaikya, sir.
Thank you, all of you. Thank you, Shwetali ma'am. Thank you, Shreya ma'am. Thank you, Chetan sir. Thank you.
Yes.
Thank you, Director ma'am.
Yeah, thank you. Thank you, all of you.
Thank you. Thank you very much.
Yeah. Yeah.
Thank you. So participants, you can leave the meeting now. Thank you.